In addition to the interaction in the Pimcore admin interface, you of course also can use the PHP API to interact and work with the workflow of elements. For that, there are two basic concepts you need to know about. First is the really interaction with the workflow elements, like checking if a certain transition can be made and applying certain transitions. And the second thing is to use all the events that are fired during the workflow to customize, to extend, to react on certain events and add your additional custom business logic. First of all, using the API to modify the places for the elements. For that, by default, you can use the standard Symfony workflow registry, which is standard of the Symfony workflow module, and with that you can get certain the workflows for certain elements, and then you can check if certain transitions can be made, and if they can be made, you can apply certain transitions to the workflow. In addition to the Symfony workflow registry, there is one specific Pimcore workflow manager, which is an extension to the Symfony workflow registry and allows you to do some Pimcore specific things, like applying additional data that can be configured and applied to certain transitions. And this workflow manager is also a Symfony service, so it's registered in the container. You have to inject it to your controller, to your services, and then can use the apply with additional data method, which allows you to apply additional data when executing certain transitions. And the second big thing is using the events for additional functionality. And there, of course, you can use all the Symfony events that are fired by default by the Symfony workflow engine, which are, of course, described in the Symfony documentation. And in addition to the Symfony events, Pimcore fires two additional events which are connected to the global actions, which are a Pimcore specific extension of the workflow module. Following the same philosophy as Pimcore itself and also the e-commerce framework, also the customer management framework is a framework that provides you a set of modules that you can use to build your own application and, of course, to customize. And the modules that are provided by the customer management framework are visualized here in this modules and architecture overview. And let's just discuss all of them in a really quick way. The data entities are the data entities that are provided by the customer management framework. First of all, of course, the customer, which is the customer data itself, then the activity, and also the customer segment and customer segment group. Customer are Pimcore data objects. Activities are not stored as Pimcore data objects, but stored in a different way, which is managed by the activity store, which is part of the activity manager we see below the data entities. The customer segments and the customer segment groups are again Pimcore data objects, and the assignment of a customer segment to a customer is nothing else than a simple Pimcore data object relation. Customer segment groups are the groups of customer segments, like for example we have the customer segment group gender, and there we have the customer segments female and male, for example. The activity manager is responsible for managing all kinds of activities and also providing functionality for tracking activities and of course for reading all the activities. There we have the activity store, who is responsible for actually storing the activities to some data storage. And we have the activity URL tracker, which is a functionality that allows you to track activities just by providing a URL to a customer. Then we have a duplicates service that sets up a duplicates index and tries to find duplicates under the customer data, which can be configured in quite an extensive way and specify which attributes should be considered in the duplicate detection algorithm and how the fuzzy logic should be set up. The segment manager is then responsible for managing all the segments and also creating the relations between the customer data objects and the customer segments data objects, and the logic of how you assign a customer segment to a customer based on which information, based on which activities, attributes, whatever, is located in so-called segment builders, which hold the actual logic of the segment assignment. These can be quite easy when, for example, we think about the segments of gender. The segment builder would just check the attribute gender in a customer object and assign the corresponding customer segment. But they can be also quite complex when it comes, for example, for calculating how price sensitive a customer is, where you can look at the latest orders of a customer and see which products of which categories he ordered, and based on that information you calculate a price sensitiveness segment for the customer, for example. The customer safe manager is responsible for all the saving of customers and also of all the validation and some additional jobs that are done when saving a customer data object, like for example setting up a data object tree based on certain criteria that you can find again your customers. Single sign-on and social logins is a functionality for the customer profile to provide social logins and these kind of things. Then we have the MailChimp integration we have already discussed. We have certain list views that visualize all the information that is managed within the customer management framework. We'll see that in the next video when we have a look at the Pimcore backend. Then we have the action trigger service, which is a way for configuring certain actions that should be executed based on certain triggers. We also can have a look at this in the Pimcore admin interface in a second. And then, last but not least, the customer management framework also provides a simple REST API to interact with all the data that is managed within the customer management framework. So we have possibility to get and set customers, to get the segments, the segment groups, the segments of customers. Of course, we also can manage the activities in both ways. So you can use the REST API to get the activities of a customer, but also to track activities of a certain customer. Before we log in into the Pimcore admin interface, let's first have a look at the big picture architecture overview of Pimcore.
You can classify the Pimcore components into classic application parts like persistence layer, like application layer, and like presentation and interfaces layer. In the presentation layer, Pimcore has a database and a file system as the primary sources and destinations for data. This is also some kind of Pimcore speciality. It not only stores the information in a database, but also uses the file system for storing and managing all the asset data that is stored and managed within Pimcore. For accessing the file system, Pimcore uses fly system, which easily allows you also to connect to cloud storage systems like S3, for example. In addition to the database and the file system, Pimcore also has an extensive cache system, which is also some kind of persistence, of course, but it's not a primary source for information. It is, as a cache system normally is, just a system that holds redundant information. And we will have a look at the cache system in later courses. In the application layer, Pimcore actually provides two parts, and everything that is in blue here ships directly with Pimcore. First of all, we have the core component, which is actually the core functionality of Pimcore, like all the documents functionality, all the objects functionality, all the assets functionality, all the commerce functionality, also versioning, workflows, scheduling, translation stuff, and last but not least also the event-driven API, which is actually quite a key component of the Pimcore core system. On top of the core system, then we have this MVC and API module, which again has parts that ship directly with Pimcore, and where you also have the possibility to add additional modules with your own bundles, with your own apps, with your own websites. What ships with Pimcore is first of all the admin interface. At this we will have a look in a second. And the second thing, in addition to the admin interface, is the Data Hub, which is available as a bundle and provides different APIs like GraphQL, REST APIs, and others to interact with Pimcore. The admin interface then, and also the Data Hub APIs, interact with client browsers or any other different API clients, which then present somehow the presentation layer. In addition to the things that ship with Pimcore, it's also always possible to extend Pimcore with additional bundles, with composer modules, with custom modules, and with all the things that are around also in the Symfony ecosystem, so you really can build very extensive applications with Pimcore. And last but not least, as we mentioned already before, it's also possible to interact with Pimcore directly with CLI commands or also with custom interfaces. So you don't need to necessarily use the MVC and the web API components. You also can run Pimcore really completely headless and interact without any user interface. Let's discuss about the toolbar of the asset editor, which provides several management features. First of all, we have the Save and Publish button, which allows us to save and publish the asset. Of course, we also can delete the asset, we can rename the asset, we also can upload a new version of the binary data of the asset. For that, we have to know that each asset has a unique identifier within the system. This ID you also can find here in the toolbar. In this case, it's 68. And with this ID, the asset is referenced to all the other elements that might need the asset. As we discussed before, we follow the principle of single source publishing within Pimcore, and so all relations that are necessary to follow this principle are based on the asset ID or in general on the element IDs. So if you rename the asset or move it to another folder, the relation still exists and is still valid. And if you want to change the binary file of the data of the asset, for example, upload a new version of a certain image or a new version of a document, don't delete the asset and re-upload it. Just use this upload new version functionality here, and then all the relations remain and places where the asset is used are updated immediately. In addition to this upload new file functionality, you also can download the original binary data of the asset. Then we have the possibility to reload the editor. Then we have this show in tree functionality, which is quite useful as it highlights the currently opened asset in the asset tree here. And then we have this information dialog, which shows additional information like the ID, like the path, but also like the public URL of the asset, the type of the asset, the size, modification information, and also a deep link to the asset, which you can send to another user of Pimcore and once this other Pimcore user opens this link, then Pimcore is opened and also the current asset is opened right away. In addition to the toolbar, we have all these tabs here which contain the preview and all the additional information and settings that can be applied to the assets. Let's discuss these tabs based on an image asset. And yeah, first of all, we have this view tab here which contains the preview of either the image or also of other file types if available. For image, we have some additional features like setting the focal point for the image and also downloading some predefined thumbnail formats or downloading formats that are defined in the system. Then also for images, we have this built-in editor that can edit the image. In this case, it provides some basic functionality and you can do some nice stuff here, but please be careful, especially when you have really big assets or file formats like TIFFs or SVG images or these kind of things, because these might be converted and you might lose some original information here. I always say this editor is more or less a pitch feature and not so much used in real life scenarios, or let's put it that way, it really depends on the real life scenarios if this edit functionality is useful or not. You can turn it off if you don't need it in the system settings. Next tab is embedded meta information, which shows all the meta information that is available for the asset. It parses the original file and extracts meta information like XMP, EXIF, and ITPC and shows this information here in this table. It's just a read-only presentation, so you cannot modify or edit this information here. The next tab contains custom metadata, which allows you to attach additional meta information onto the asset, which is stored in Pimcore and not directly on the asset binary file. Classical things would be things like a title or an alt text or copyright information, but you can add also whatever information you might want to add to your assets, so this is really very flexible. You either can modify the custom metadata directly here in this editor and add whatever data you want to add to your asset. There we have different types like an input field, like text area, links to other assets, to documents, to assets. Also we have date and checkbox. And we also can specify the language of this metadata here, and then we just add it and can edit the data here directly in the asset. In addition to inlining these custom metadata, there's also the possibility to define predefined definitions for custom metadata, which can be found here in this settings menu where we have this predefined asset metadata, and there we can define predefined metadata attributes that should be added to the assets. Let's make there a bar. Again, we can provide some description. We can again choose between the different types, and we also can then specify the language here and also specify to which asset type these predefined metadata should be added to. And then when we go back to the assets themselves, we can use this button here, add predefined definitions, and then Pimcore adds all the missing metadata attributes that are defined in the predefined settings for the assets, for this actual asset type, in this case the image. The next tab contains the properties, which are quite generic functionality that is also available for documents and data objects, and we will explain this in more detail in combination with the documents. The next tab are the versions, which are also not just available for the assets, but also available for documents and data objects. And these versions are actually the versions of the assets or the elements in general. So every time you save an asset, a version gets created, and you see exactly when this version was created and also who created this version. And you also can go back and see what data has changed during the versions. So here we see that the metadata has changed, and you also can go back and publish an older version of the asset. So with these versions, you have actually a complete audit trail of all the changes that were made in combination with the current asset. The next tab is the schedule, which is tightly connected to the versions, because this schedule allows you to define automatic actions that, for example, publish at a certain date and time a certain version of the asset. So for example, we have a Christmas special version of an asset and we want to publish this at the 24th of December. This can be done here with the scheduler. So we can define a date, we can define the time, we can define the action. So for example, want to publish a certain version here, and then we select the version and can say, okay, please publish this Christmas special at the 24th of December, for example. The next tab is the Dependencies tab, which is just an information tab that visualizes the single source publishing principle of Pimcore. With this tab, you have a quick overview of where the current element, in this case the current element, is used, and also what other elements this current element is using. So in this case, our asset does not require any other elements, so it does not require another asset or a document or a data object, but this asset is required in 2 data objects, and so we have a good overview of all the relations that this asset is in, and of course we also can follow these relations. So for example, we can open up the data object here and see where this asset is used. Then the next tab is the Notes and Events tab, which is again similar to the properties, a very generic feature that again also is available for documents and data objects, and we will explain that functionality in a later course. The last tab I want to discuss now is the Tags tab. The Tags tab is again also available for documents and data objects, but let's just discuss it in the context with the assets, because the pretty typical use case for the tags is in combination with assets. For tags, you can configure a system-wide tags tree. You can configure this here in this settings menu, and this tags tree can follow any structure you need for your use cases, and so it can be used for setting up additional taxonomies, additional categorizations for your elements, whatever you need. And once you have set up the tags tree, you can go back to your data elements and assign these tags to your data elements. So for example, now we assign United Kingdom to this asset because it shows a car image of the United Kingdom. It's a low-res image, and we, for example, allow it for teasers or whatsoever. And yeah, as soon as I have tagged my images, I can use this tag information then on different places. Of course, I can use it on all my output channels where I want to deliver the data to, for example, for filtering and these kind of things. And within the Pimcore backend, there is also a place where I can use this tag information, and this place is the search. So when I search for assets, for example, I can there filter my search for tags, and let's maybe filter for United Kingdom images and also for teaser, and then it already filters down just for all our assets that we have tagged before. So in Pimcore backend, you can use the tags for filtering in the search and also in the grids. But as I said before, you also of course can use the tags for different use cases in your output channels. So, and last but not least, if we have a look at the other asset types, like the document, for example, here, we see that there are a few less tabs available, especially the edit tab is not available for other asset types, but the other tabs and the other information and functionality works the same as we saw for the images.
Hello and welcome to another session of Pimcore Insights. This time it's all about workflows. Pimcore ships with a built-in workflow engine that allows you to configure workflows on each data element of Pimcore, which means on documents, on assets, and on data objects. This workflow engine is based on the Symfony workflow module and extends it with a few Pimcore-specific features. That means that you can reuse all the knowledge, all the know-how that you have from the workflow module of Symfony, and also, of course, you can reuse all the events and all the APIs. Let's have a look at the basic concepts of the Pimcore workflow engine. Of course, we have this all in our documentation, and yeah, Pimcore workflows have the workflow, which is the basic model of the process that an element can go through. And this workflow consists of multiple places. The places are actually the states that an element can be in. The place information is then stored in the so-called marking stores. And yeah, the default marking store is an additional Pimcore table, but you also can use different marking stores and, for example, store all the place information directly in the data objects. Depending on the workflow type, an element can be in one place at a time, which would be the workflow type state machine, and it can also be in multiple places at a time. This then would be the workflow type workflow. Then there are transitions, which describe how you can get an element from one place to another place. And yeah, for these transitions, there are also so-called transition guards, which can define criteria if a transition is currently allowed or not. In addition to the transitions, which are always connected to certain places, and there are also so-called global actions, which are actions that can be executed in any place in the workflow. So they are globally available, and yeah, besides that, they work really similar to the transitions. The configuration of the workflow takes place in Symfony configuration files. We'll have a look at this configuration later on in detail. As I already mentioned, the workflow engine fires lots of events, which you can use to customize and extend the functionality of the Pimcore workflows. There are, of course, all the Symfony default events, and in addition to the Symfony events, there are also a couple of additional events that are fired directly by Pimcore. Besides the events, you have also the possibility to configure certain user notifications directly in the workflow configuration. This notification right now is an email configuration where you can specify under which circumstances, which users or user roles should be notified. And you also can specify the mail template that should be used. This is always a transition configuration, so the notification always takes place while a transition is executed on the workflow elements. If these user notifications are not sufficient for your use cases, you always can use the events and build your customized notification system. And then there are two more things that work out of the box with Pimcore workflows. First of all, the workflow history, which is a full audit trail of what happened to the element during the workflow, so which transitions were executed by whom and when. These informations are stored in the nodes and events of the Pimcore elements. And in the last but not least, there is a workflow overview tab, which shows all the workflows that are active for a certain element and also visualizes an overview of the workflow, so a graphical representation, and also visualizes the place the element is currently in.
Let's start with the configuration of a portal with Pimcore documents. Every portal is set up as a site with a separate domain and a couple of subdocuments that define the structure and the content of the portal. So, as with any other Pimcore application, the document tree here defines the basic structure and also, of course, the URL structure of a portal. The portal page itself has a couple of global settings, like the portal name here, like a logo, a background image, footer snippets, and a couple of more, and should only be available once per portal. In terms of content, we have two types of content. First of all, we have classic editorial content, which is managed with classic Pimcore document pages, like this one here, for example, where we also have the possibility to compose these documents with area bricks and so put in all the content that we want to have. And then we have the actual data in terms of the displayed assets and data objects, which are set up in data pools. And the data pools are again set up with special documents, which contain all the settings that are available for a data pool. For all the different document types, we also have the predefined document type set and available. So there we have this portal page, we have this classic content page, we have the asset data pool configuration page, and we have the data object configuration page. And then last but not least, we have the data pool language variant, which already leads me to the next topic, which is multi-language portals. In terms of languages, we have two types of languages. First of all, we have the front-end language, which defines the language of all the labels and all the buttons and these kind of things. And then we have the content language, which describes the content and the multi-language content, which means the metadata content and also the localized fields contents of the data objects. In terms of the content language, we always display all the configured languages independent from the current front-end language of the portal. And the front-end language of a portal is set up again with standard Pimcore features by creating a subtree for every front-end language we want to have and setting the language in the document settings itself. There is one speciality though, in combination with data pools, because we don't want to configure the data pools multiple times. We have this special document type for the language reference, which allows us to reference the original data pool configuration in each additional language. That means we set up the data pool configuration just once in the first language, and then for each additional language we just reference to this original data pool configuration. In general, it's recommended to use the Portal Engine Setup Wizard to set up the portals, because they just create you already all the documents, all the structures, all the sites and these kind of things. But it's also of course possible to start from scratch and set up the portal just by hand by creating all the different documents.
Now that we have a big picture overview, know how the portals look like and what out-of-the-box features they provide, it's time to have a more detailed look under the hood. To understand how the Pimcore portals work, it's important to know about the following concepts. First, Pimcore portals are standard Pimcore applications, and therefore we're trying to reuse as much Pimcore functionality as possible. For example, we're using Pimcore documents for the configuration of the portals. Second, the configuration of what data should be available in a portal takes place in so-called data pools. Data pools exactly define what content should be available and what actions are allowed, and therefore they are somehow the heart of every portal. Third, user management is implemented with Pimcore data objects and allow to define permissions and access rules based on a classical user role-based system. And last but not least, all the listing, searching and filtering is done based on Elasticsearch. Therefore, certain index management and especially indexing of the data is necessary. Let's have a more detailed look at these concepts.
The user management is implemented with Pimcore data objects. There we have two different data object types. We have the portal user and we have the portal user group. Let's start with the portal user group, where we can specify lots of different permissions to specify if a certain user should have access to a portal, to a data pool of a portal, and even access to certain features of a data pool of a portal. In addition to the permissions, we also can specify workspaces. These are global workspaces that define for users what content they should have access to and what content they should not have access to. These global workspaces then allow to further restrict the available data of a data pool for a certain user or user group. They don't extend the workspaces of a data pool though. So we have a two-level workspace system there. First, we define the workspace for a data pool to define the base set of elements that should be available in this data pool. And then, additionally, also the user needs to have access to these elements in his workspace settings to be really able to access the certain elements. This allows quite sophisticated configuration of workspaces and also really fine-grained permissions in terms of what user groups should have access to what data in what data pools. Similar it goes with the content languages. Again, we can configure them on data pool level and then further restrict them with the global user settings here. Besides the group objects, we have also the portal user objects, which represent actual users with an email, first name, last name, and so on. Then, of course, we have the possibility to assign one or multiple groups to the user. And in addition to assigning the groups, we also can define the permissions, workspaces, and languages on user level, and then all the permissions and settings of the user with all the assigned groups is merged to get one permission set for the currently logged in user. Additionally, we also have the possibility to make a user an admin user, and an admin user then sees everything and is allowed to do everything. Then there's one more thing we need to discuss here, which is this checkbox or this combo box here. We decided on purpose to use Pimcore data objects for user management to be a bit more flexible, but there are some use cases where it makes sense to have a link between a portal user and the Pimcore backend user. For example, to have proper owner and modification users set in the data when updating assets, to just name one of them. And for that, we have the optional possibility to assign a Pimcore backend user to a portal user with this combo box here, where we can set the corresponding relation here. If there is nothing set, then Pimcore automatically uses this portal engine default user to have a default relation between a portal user and a Pimcore backend user. If a specific user is assigned, then we also have the possibility to use the Pimcore backend password for authentication instead of using the password that is specified here in this portal user data object, and this we can do by just checking this checkbox here. As already mentioned, the configuration of data pools also takes place in documents. There are lots of different settings for data pools, like workspace settings, like navigation settings, like filter definitions, like sort options, like detail page configuration, download configuration, and also language configurations. Also, the available settings differ a bit between the asset data pools and the data object data pools. Nevertheless, the probably most important setting is the workspace definition, because it defines what content is available in the data pool and what actions are allowed to this content. Setting up a workspace is done by just adding block entries here and assigning a certain folder, either an asset folder if you are setting up an asset data pool or a data object folder, and then defining the permissions you want to allow for this certain folder. So this is quite similar to the user permissions and workspaces in the Pimcore backend, and this allows you to set up all the elements that should be available in the data pool, and therefore also, of course, in the portal. If for whatever reason you need a more advanced option to set up the data pool, you can also add an additional precondition service here, which is a Symfony service that you need to implement and register first. And this Symfony service then allows you to further filter down the available elements by whatever condition you implement there. For all the other settings, just have a look at the documentation. They should be quite self-explaining though, so just play around with them and you will easily see what they help you to set up.
Another option to inject custom functionality into the Pimcore data entities are so-called class overrides. They are not restricted only to data objects, but are also possible with assets and documents and allow you to inject custom functionality in all these data entities of Pimcore. To see how they are working, let's just make an example with data objects. The first step is again to create some custom implementation that you want to use for the overriding. So let's just create another PHP class. In this case, we call it custom test class, located again somewhere in any bundle in some namespace that is visible to Pimcore. And of course, there is again one requirement. You need to make sure that the class hierarchy is still valid. And in this case, you need to make sure that you extend the class you want to override. In our use case, this is now the Pimcore model data object test class. If you would override asset functionality or document functionality, you would need to override the asset image class, for example, or the document page class, for example, or whatever class you want to override. After that, you have again all the possibilities in terms of specifying your custom functionality, like adding some values or methods here. Let's just add another method which returns again some random values, and make sure that this, of course, contains all the functionality that you want to inject. The next step is that you need to tell Pimcore that it should use this custom class instead of the standard default class. And this can be done with Symfony configuration. Let's just open up our configuration file. And in our installation profiles with the demo applications, we have already a few sample configurations, like, for example, this overriding sample here. And let's just use this sample here and adapt it to our needs. So let's make sure that we have a Pimcore setting, and in the models namespace class overrides, and there you define the class map that should be used for the overriding. In this case, we want to override the Pimcore model data object test class with our app bundle model data object custom test class here. Custom test class. And this was already all the configuration stuff that we need. And the only thing that is now left is that we need to make sure that we clear the Pimcore cache, because otherwise items might be loaded out of the cache and their class overriding setting is not considered. Right now, everything is set up, and every time Pimcore loads now a data object test class, it will instantiate a custom test class instance and delivers this object. And now, of course, we also can test this. Let's go back to our default controller, where we have already prepared loading an instance of the test class. And now we can call the method that we just defined on our custom test class. And when we execute this now, then we'll see that Pimcore loads the correct classes and delivers us the correct return values. As I said before, the class overrides not only works for data objects, but also for all the other Pimcore models like the documents, the assets, and also the listing instances, and therefore it's a quite powerful possibility to inject custom functionality to all the Pimcore default classes. Sometimes you might have use cases where you have hundreds of different categories with in total thousands of different attributes which you need to manage and handle. And this at some point will blow up the object bricks because they are not designed to having this amount of different object bricks on the one side and different attributes on the other side. The user interface is not capable of using hundreds of different object bricks, and also on database level, too many tables will blow up the database at some point. And this leads us to the second way of dealing with category-specific attributes, which is the so-called classification store. The classification store now is designed of having hundreds of different categories with thousands of different attributes, and also of modeling classification systems like an E-class or an A-team. Let's switch back to Pimcore backend and have a look how this is done within Pimcore backend. First of all, we again have to go to our class definition where we need to add an additional data attribute. And this time, of course, we need to add a classification store data attribute, which is again located in the structured section. And the classification store, of course, needs a name. And this is pretty much all we need to do in the class definition. The classification store itself now is again defined in a central place in Pimcore, similar to the to the object bricks and also to the field collections. And this is again located here in the data objects menu and called, well, classification store. Within the system, you can define different classification stores, so multiple classification systems also. Let's just define one default classification store, and each of these classification stores needs to have at least different keys and different groups. The keys are more or less the attributes that you want to manage. Like, for example, let's just put a few attributes here like height and width and maybe a weight attribute. And these attributes all can have, again, different data types, but at this time, the different data types are very much restricted to only the simple data types. You cannot have, for example, things like relations and these kind of things. So this is really reduced in terms of the different data types that are available. For all the data types that are available, you have again the same settings as you have for the data types in the data objects or in the object bricks, like defining the format, defining some validation rules, and these kind of things. Once you have defined all the keys, the next step is to define the groups, which are actually a collection of keys. Let's, for example, define a dimension group where we add all the dimension attributes like the weight and the width, the height and the width, for example. On group level, you can define a few additional things for all the keys. You can define whether they should be mandatory or not, and you can define a certain sorter to define the order of which they should appear within the group. And then let's define another group, weight, where we add the weight attribute here. And that's pretty much it. Optionally, you can also define collection of groups. This is just a combination of different groups. And this is optionally can be done, but is not necessary for the classification store. So once the classification store is defined, we now go back to our test data object, again to the data attributes here. And there we see already the store attribute, which is the classification store attribute we just added. And there we have the possibility to add now keys. And there we see already why we need to define either groups or collections, because you only can add groups or collections of the keys. You cannot add keys separately. Let's add just, for example, our dimension group and also our weight group, for example, and this results in adding additional attributes to our data object class with, of course, all the keys that we defined in the classification store. And there again, I can define all the values I want to add and, of course, store all these things. The classification store also, of course, supports data inheritance, which means when we open up our sub data object, we see that all the attributes are inherited from the parent object, and of course I can override the values again on attribute level. And the inheritance for all the other attributes of the same group or in general of the whole classification store still inherit the values from the parent. Layout-wise, the classification store is also much more restricted compared to the object bricks, because the layout that we see here is the only layout that is available. So you always have the groups of attributes in these field sets, and then have all the attributes, all the keys of the group below each other within this field set group. There is no other possibility to change the layout in any way within the classification store. When it comes for the database, the classification store now follows a different approach than, for example, the object bricks. The classification store stores all the data as the entity attribute value database model, which means that for each attribute we have an additional row in a very long table. The classification store table is again class specific, so we have a classification store table for each data object class, and they are always named classification store, data, and the class ID. And when we have a look at the data of this table, we see that for all the different attributes we have an additional row, and the value is stored in this value column here. This of course has some consequences when it comes for filtering and searching for the data, which is not so easy anymore. It's a bit more complex. And of course, also performance-wise, you have to query a potentially very, very long table, which might result in some additional query time.
Another part of administration of Pimcore is to make sure that everything is set up correctly, especially when it comes to configuration and maintenance part. Pimcore provides warnings related to misconfiguration of the system under Notifications menu in the left toolbar. These warnings are related to debug mode, which means it is enabled for the application, maintenance task which is not set up properly, and email settings which are missing for the application. In the production system, you should not see any of these warnings. Debug mode enables Symfony debugging toolbar and other debugging tools. It should be used only for development purposes. So it is important you should disable it for the production environment. You can enable debug mode by setting the app env environment variable in your project root.env file and sets its value to dev and reload the application to see changes. In production, this value should be prod, and for test, it should be test. The email settings are used for sending emails and newsletter from Pimcore application. These settings are configuration that are configured in Pimcore config node. You can configure these settings in your main config.yml file. So there are two kind of email settings. General email settings, which are used to send transaction mails, or which Pimcore uses it internally to send notifications and so on. In addition to general email settings, there are newsletter email settings, which are optionally configured for different sender address, when sending newsletter documents to the receivers. As Pimcore email framework utilizes Symfony Mailer to send emails, it is also required to set Symfony Mailer transports, main for sending emails and Pimcore newsletter for sending newsletters. In addition to email settings configured in the config YAML, you can also configure debug email address in admin UI, settings, system settings, debug section. This email address is used when the debug mode is enabled and all the emails will be sent to this address. And the maintenance setup is an important step that you need to follow during the installation. You have to set up the cron job which executes the maintenance task in regular intervals, which allows Pimcore to do cleanup, log rotation, and other important tasks. If you don't set up maintenance job, then you end up with unnecessary utilized storage, and your application performance will be impacted. How to set up the maintenance job? You find it in the documentation in installation part where it says maintenance cron job. This is the cron job that you need to install and configure in order to make sure that the maintenance is executed properly. Don't mix up the maintenance cron job with the maintenance mode that you can activate in the Pimcore backend. The maintenance mode can be activated in the admin UI under tool menu. Once you activate the maintenance mode, only you can access Pimcore from current browser session. All other users and console application that tries to execute Pimcore will see maintenance page. You can also customize this maintenance page by overriding the maintenance page listener service and providing your custom view file. This maintenance mode can be used for system maintenance, which requires performing migrations and making sure that nobody else is interrupting during the update. If you want to deactivate maintenance mode, just click the stop button on the left toolbar. If you lose control from your current browser session, there are other possibilities to deactivate the maintenance mode. One way is to run the console command pimcore maintenance-mode, and with this command you can either disable or enable the maintenance mode through console. The other way is to remove the file on the file system. So under var config maintenance.php. This is the file which is generated when you activate the maintenance mode. So if you delete the file, this will deactivate the maintenance mode for all the users.
Hello and welcome to this session of Pimcore Insights. This time it's all about caching. Pimcore ships with a quite advanced caching system to optimize reading performance, and there are a few aspects you should know about this caching system. Let's start with the core cache, which is by default always activated and caches all the data entities like data objects, assets, and documents that are managed within Pimcore. Actually, this core cache consists of two caching levels, which are first of all an in-process memory registry, and the second level is the actual cache backend. The in-process memory registry should avoid loading the same item multiple times, and when loading a new element, the first check is if this element is already stored in this in-process memory registry. If not, then the next step is to check if the element is cached in the cache backend, and only if it's not cached in the cache backend, then the data is loaded directly out of the database. Once the data is loaded from the database, it's scheduled for caching by adding it to a caching queue. It's not cached immediately in order to improve performance and not reduce the performance due to the caching process. The actual caching then takes place after the response is sent back to the browser in the kernel terminate event, and then the caching queue is processed and 50 elements of this caching queue are stored into the cache backend. The reason why only 50 elements are stored into the cache backend is that during one request there could be thousands of elements that are loaded and would be needed to written into the cache, and in order to avoid very long running processes and also to avoid memory inconsistencies, the caching queue is only processed with the 50 most important items. This is quite an important information because when you observe the behavior of Pimcore applications, then you will see that the cache is filling up constantly on each request, And if you repeat one request multiple times, then you will see that the performance increases by every request, because after every request, more elements can be loaded out of the cache and less elements need to be loaded directly out of the database. The core cache is, as I mentioned already, activated by default, and it's recommended to not deactivate it because it significantly improves the performance. And normally you shouldn't even get in touch at all with this core cache, because Pimcore takes care of all the cache invalidation and always makes sure that the cache and the data within the cache is consistent all the time. As cache backend, we recommend to use Redis. If there is no Redis available and Redis is not configured, Pimcore still uses the core cache, and as cache backend in this case, Pimcore uses a MySQL table, which is called the cache table. This is actually a table that is always available and uses the memory storage engine, and yeah, it is used as the cache backend if there is no Redis available and configured. If for whatever reason you need to deactivate the cache, this can be done by using the cache API, and there actually you can disable it, you can of course re-enable it, and you also can clear the cache or clear certain tags. Tags are used to make an advanced cache management, to make it really smart in order to not clear all the cache all the time, but only the elements that need to be cleared out. And yeah, the tagged caching is actually the principle and the concept that Pimcore uses to make a really smart cache management and always make sure that all the cache items are up to date. In addition to the default functionality of caching and all the automatic caching of all the Pimcore data entities, you also could use the Pimcore cache for your custom items that might be quite expensive to calculate, like for example, as we see here in this example, making a certain HTTP call to an external resource and cache this item. So you always can use the Pimcore model cache here to load items and of course to save items and put the data into the cache and load it from there the next request. But as said before, normally, unless you don't use the cache for your custom items, you won't be getting in touch with the cache, and it should work out of the box fully automatic.
Data Hub has a nice integrated interface called iExplorer, which is an IDE for GraphQL. You can open this Explorer in iframe within the Pimcore or in New Browser tab. So let's open it in iframe. You can check the Document Explorer to see what query and what mutations you can pass to the API endpoint. And in this documentation, you can check all the datasets and the dataset types that we can pass in the query. So let's write a small query here. So I'm writing a get asset query and I'm passing an ID to the get asset query, and I would like to see the full path in the response. So I'm gonna prettify my query here and click on execute. So you see we have the response from our API. Now that the Data Hub plugin is installed and enabled, you can create new API endpoint. To do that, go to Settings, Data Hub Config. In the Data Hub config panel, on the left-hand side, you see already created endpoints. So let's create a new endpoint by clicking on Add Configuration button, selecting GraphQL channel. We need to provide a unique identifier which can be used to access this API. So let's provide a name and click OK. A new API endpoint is created, so we can define some configurations for it. Starting with general, we can define active inactive status, which activates and deactivates the API endpoint. We can define some nice description, and we can also define an SQL condition, which will be applied on all the queries in this API endpoint. Moving on to schema definition. A schema definition is the core configuration of the Data Hub APIs. Schema basically defines the type system, where you can describe all your data sets that can be queried on APIs. Here, we have option to define query schema and mutation schema. A query schema is a structure that can be used to fetch the data from Pimcore, and mutation schema is the structure that can be used to add or update data into Pimcore. And we can also define schema for generic types like documents, assets, and folders. Now moving on to security definition. In the security definition, we can define security method for API authentication process. When API key is selected as security method, we need to generate an API key, which is a token used to validate a user or program calling the API endpoint. And in addition to this API key, we need to provide workspace permissions for elements in Pimcore so that we can create, read, update, and delete these elements. And we can also skip these workspace permissions by clicking on the skip permission checkbox. Once the configuration is done, we can save it by clicking on Save button. Once you have created and configured your API, you can access this API with a standard endpoint, which is /pimcore-graphql-web services/configuration name, which is a unique identifier provided while creating an API endpoint in Pimcore. And you need to provide an API key for authentication. So if your unique identifier is block demo, then your URL endpoint will be Pimcore GraphQL Web Services block demo, then your API key. You can also override these endpoints in your routing via ML by providing a new path for admin Pimcore Data Hub config for overriding iExplorer endpoint. And you can also provide new path for admin Pimcore Data Hub web service, which is a endpoint for accessing the web service. When it comes to defining custom icons for data objects, there are two ways to define them. The first way is the static approach, in which you can define custom icon on class level in the class definition, and this has then of course the result that all the data objects of the same class will have the same icon. The second way is the dynamic approach, in which you can define custom icons on object level with your own implementation of admin style element. The admin style element is an object class that is responsible for returning certain style definitions and also CSS classes for the elements based on the data of the element. So with this approach, you can define different icons based on the different data that is stored in the data object. And this can be achieved by adding an event listener to the resolve element admin style event. So in your services YML, you define the admin style listener, and in your admin style event listener class, you attach your own implementation of admin style class. So let's go to the IDE and let's check this custom admin style class. So let's take an example of our demo cars data. So here we define that if the car object has a type actual car, then we use a different icon for the element tree. Otherwise, we just use the icon that is defined in the class definition. So let's go back to the Pimcore admin and let's check the cars object. So here you see when we have our object type as virtual car, then we use the icon from the class definition. And when the type is actual car, then the icon is used from the admin style custom implementation. In addition to defining the icons and CSS classes, you can also define the custom tooltips that shows additional information on just hovering over the data objects on tree.
Custom layouts can be configured directly in the class definition dialog by using this Configure Custom Layouts button here in the top. And yeah, custom layouts allow to define additional views on data objects with different attributes, most likely a reduced attribute set. Let's just add an additional layout. Let's just add a test layout here. And in this custom layout definition dialog, you see on the left side all the attributes that are available in the class definition. And now you can rearrange these attributes in your custom layout. So again, you can use all different layout components. For example, also could add additional text items to explain certain things or whatsoever, and then add one or another attributes to the layout components. For example, right now I just added all the localized fields to my custom layout, but I don't want to add the date, the categories, or the poster image, because this is, for example, just a translation custom layout that should be used by users who translate the content. And once this content is saved, then I can open up, for example, an article data object, and there I can now switch between the custom layouts and, for example, just load the test custom layout, and there I already see now I only have available just the localized fields but not the other attributes anymore. And when I switch back to the master layout, for example, then I see again all the attributes that are defined also in the master layout. We have one additional layout here in the reload button, which is only available to admins. And this admin or master layout for admin mode is a special functionality that loads the data object in the master layout, but also activates all read-only fields to be editable. So this is sometimes quite useful for admin users. Custom layouts also can be configured in the user settings in terms of permissions. That means I always can specify in the workspaces which custom layouts should be available for a certain user group. And that of course means that I can restrict certain user groups to certain custom layouts so that they only see certain custom layouts and, for example, not the master layout. Important to know at this point is that custom layouts are not the way to hide attributes that are really classified and must not be sent to a certain user group. Because when you specify a certain custom layout and load an object in a custom layout, still all the data is sent to the client, even if it's not visualized in the user interface. Let's just have a look here at our blog article. Just reload it. And there we see the GET request, which actually sends all the data to the client. And when we open this up in a new tab and see what data is sent there, then we see the data is sent here, the localized data, but not only the localized data, but also the date, the categories, so all the additional attributes that are not visualized and visible in the custom layout. It's just important to know that the data is still sent to the client, and therefore maybe the user still sees classified content, and therefore the custom layouts are not suitable for really hiding classified content from certain user groups. The custom reports can be specified directly within Pimcore backend interface with this custom reports section, where you can create your reports. Of course, you have some general information like name, like icon class. You can group your reports. You can specify a certain group icon. You can specify a shortcut in the menu. But the most important thing then is that you can specify the source of your data. For example, you can choose MySQL data reports, you can choose analytics reports. You also can add additional data sources here by extending Pimcore. Let's maybe just add an MySQL type and just create an asset report where we select the type and the count of assets of a certain type, and we need to group them by type. Then we get an overview of all the columns that our SQL statement produces. We can specify some things like the width of the column, the label of the column, and also filter options. And optionally, we also can specify charts for our report. Let's, for example, define a pie chart which visualizes the types and the counts. And then we can share these reports either globally or with certain users or certain user roles. Let's save the report and reboot Pimcore. And once you have specified your reports, you can open them up in the reports section. There we have, for example, our assets report, and there we see the data and also the chart visualization. Custom views allow you to define additional trees to the main trees of documents, assets, and data objects. And yeah, you can define subtrees, special subsets of the elements that are in the main trees, and visualize them in additional accordion entries, like you see here in the screen, where you have some blog objects, which are only the blog objects, or where you have a certain accordion entry which only has certain documents of a certain subtree. The custom views are defined in a configuration file where you can specify all the custom views that you want to be available in the system, and there you also can define things like additional name or an icon or a root folder or additional conditions for filtering out the data. On top of the custom views, then you have the possibility to define the whole appearance, the whole perspective of the user interface with the so-called perspectives. And the perspectives actually do mainly two things. First of all, they define which menu entries should be available in the current perspective, and then they also compose all the custom views of the accordion entries to define which should be on the left side, which should be on the right side, which should be expanded, and so you can really customize the appearance of your user interface. Perspectives are the same as with the custom views, configured in a configuration file where you can define all the settings. Let's just have a look at our advanced demo, how this can look like. There we have defined a couple of perspectives, and there you see when we load the perspectives that the appearance of the Pimcore user interface in terms of which accordion entries are there, in terms of which menu entries are there, really can be completely customized. What is also possible, of course, is that you couple these user perspectives again with user permissions, exactly with users and with roles. So you can specify which users or which user roles should have which perspectives available. And so you can, of course, reduce and restrict the whole Pimcore user interface to really just the needs of certain user groups.
Another interesting part of the CMF is the Customer Duplicates Index. It helps you to identify duplicates within your customers and consists of three major parts. The first part helps you to identify exact matching customers. The second part is called the Customer Duplicates Index and helps you to identify fuzzy matching duplicates. And the third part is called the Duplicates View and is a user interface that shows potential duplicates based on the duplicates index and lets a user decide whether these potential duplicates are real duplicates or two separate customers. Let's start and find some exact matching customers. For finding an exact matching customer, let's create ourselves a customer first. For that, we again use the customer provider. Let's set this to active too. And then we can inject ourselves the customer duplicate service, which is a Symfony service that can be injected. And now let's use it to find some duplicates for our customer. And now we just load all the duplicates and print it out and see if in the system there is any duplicate customer. And there is a customer that matches the customer we just created, and this customer has the ID 1156. Which attributes are used for this exact matching comparison can be configured in the customer management framework configuration. In the customer duplicates service, there we can specify this duplicate check fields. We discussed this already in one of the previous courses, and this configuration here right now says that either the email address or first name, last name, zip code and street needs to match in order to have an exact matching duplicate. This customer duplicate service functionality can also be used in combination with the customer safe validator. Once this check for duplicates field is set to true, the system checks automatically when saving a customer if there is an exact matching customer. And yeah, let's maybe just quickly try that. If we save the customer we just create, or at least try to save it, we should get an exception that there is a duplicate customer found. To find fuzzy matching duplicates, it's necessary to activate and configure the duplicates index. The duplicates index is a special storage that stores the customer data in a special way in order to make the fuzzy comparison possible in a very performing way. By default, the storage is storing the data into the MySQL database in a special table, but it's also possible to add implementations that store the data, for example in Elasticsearch, to even improve the performance for very big data sets. The duplicates index can be activated and configured in the Symfony configuration tree in the customer management framework section, customer duplicates service, and then there the duplicates index. And there you of course can activate or deactivate it, and then define which fields should be considered in the duplicates finding logic. And there you can configure so-called field combinations that should be compared with each other. In this case, we have two combinations. We have one combination that contains last name, first name, zip, city, and street, and we have a second combination that just contains the email field. For each of these fields, of these field combinations, there are additional settings that can be configured, which define how the data should be stored into the duplicates index and how the comparison should take place. And actually there are three important settings, which are soundex, metaphone, and similarity. So for each field you can specify whether you want to use soundex comparison, whether you want to use the metaphone algorithm for comparison. And yeah, having soundex and or metaphone often produces many false positives, and to prevent these false positives, it's possible additionally to define a similarity matcher, which is executed when soundex and or metaphone find a potential match. Then the similarity can further check if these potential matches are a real match or not. In addition to the similarity, it's also possible to define a custom similarity threshold, which would override the default threshold that is defined by the similarity matcher implementation. There are a couple of default implementations for the similarity matcher, but you always can of course also provide your custom implementations there. In addition to the duplicate check fields, it's also possible to define data transformers for single attributes, which are executed before the actual soundex metaphone similarity execution is taking place, and these data transformers can transform the data, make it a bit easier, remove certain special characters, or switch for special abbreviations or something like that, so that the comparison is even better and the matches that you find are even more accurate. Once the duplicates index is activated and configured, it needs to be filled, and filling the duplicates index is done by executing a console command which is called cmf duplicates index. This console command should be executed also as cron job and has three options. First option is to calculate potential duplicates. Second option is to analyze false positives in order to log them. And the third option is to recreate the whole index. This also might be necessary sometimes. Once the duplicate index is filled, then the third part of the customer duplicate service kicks in, which is the duplicates view. Let's just open up this duplicates view in our demo application, and there we see that this duplicates view shows the potential duplicates that are identified with the duplicates index to the user, and the user now can decide if these potential duplicates are real duplicates and need to be merged, or the user can decline the potential duplicates and say, no, these potential duplicates are actually two different customers and they should be kept separate. When merging the customers, an additional merging view opens up with all the attributes of the customers, where I can merge the data and really create just one customer data object out of two. Setting up the customer duplicates index is quite a complicated task, and you should really plan some time for setting it up properly, for trial and error, learning the data, learning the behavior of the different data attributes and similarity calculations, and to set this up properly.
On class level, there are a couple of additional options and configuration possibilities for developers to modify the default behavior of the classes, some of which we will discuss in later courses, but one of these options we need to discuss right now, and this is the allow inheritance functionality. Before we activate this, let's just create, for example, a categories tree where we not just have a few categories in one level, but add additional levels to the categories. So let's have there a subcategory and maybe another subcategory. And by default, these subcategories, of course, have now no name set because we didn't set the name. And let's just add some name to one of these categories. If we activate, though, this allow inheritance feature of Pimcore, we activate the so-called data inheritance feature for this product category class. And that means that automatically all data is inherited along the tree to sub-objects. And for example, now if we open up a subcategory now, which has no name set yet, and reload this, then we see that now the name is inherited from the parent category. We see that because it's so gray and we have this green edge here, which we can click and open up the source of the actual data. Of course, we can override the data anytime by just clicking into the field and writing additional data in there. And at this point, the data inheritance is broken. In the context of categories, this data inheritance maybe makes not so much sense, but for example, in the context of products, it makes much more sense and again reduces a lot of data management effort, and also is again such an aspect of the single source publishing principle. For example, when I have products like t-shirts, where I have one t-shirt that is available in different colors and different sizes, then I, for example, can set up such a hierarchy where I have the base product with all the base attributes, and then below this base attribute I set up all my color variants and only override the color field, and then for example I set up all the size variants and only override the size fields, and all the other attributes are inherited from the parent products. The data inheritance is not just for one level, it goes even deeper. So for example, when I now here create a sub-sub category, also this sub-subcategory can inherit the data from any parent of its parent objects. In theory, this hierarchy can be endless, but be careful, at some point you will have performance impacts when you have about 20, 30 levels of different inheritance levels. So really, yeah, keep in mind that on the one side, also the editor might not understand the hierarchy structure anymore, and on the other side, there might be performance impacts when you have a too deep hierarchy when it comes for data inheritance. When we hit the Save button here in the class definition dialog and save the data object classes, Pimcore does not only create the editor for data objects, but does a few other things in the background too. And yeah, let's have a look what Pimcore actually does. First of all, Pimcore creates a so-called definition file, which actually holds all the definition of a certain data class. And this definition file you find in the private var folder, here in the classes folder, and there you have all the definition files that are based on the data object classes you have in your system. For example, when we have a look at our demo product category, here you find the definition file for it, and actually this definition file is only a serialized PHP array that holds all the information that is defined within the class definition dialog. In our case, we have a few panels there, and at some point our input field for the name of the product category. Of course, the definition file of the demo product itself looks a bit more complex because we have a few more panels and a few more data attributes, but the principle is the same. This definition file is actually the primary source of all the definition for data object classes, and Pimcore can build up based on these definition files all the additional things that Pimcore does in the background. And these additional things are, first of all, creating a PHP API, which allow you to interact with data objects via PHP code. And the second thing that Pimcore does in the background is creating a data model in the database for the data objects. That also means that these definition files should go into your Git repository, and especially when you are using a multi-stage environment where you have some test systems and staging system and a production system, these definition files should be transferred from one stage to another, and then there is a Pimcore command which you can execute and then update all the APIs and all the database structure based on eventually updated definition files. The second thing that Pimcore generates is the PHP API. And this PHP API you find in this data object folder here. And there you already see that Pimcore creates a PHP file with actually a PHP class in it for each data object class you define within Pimcore. For example, we have here our demo product category, our demo product, and all the other entities that were already there in this demo application. And when we open up one of these PHP files, we see that this is actually the API that has getters and setters for each attribute that you defined in the class dialog. In our product category, we have just get name and set name. In the demo product, we have some more additional getters and setters for all the additional data attributes like name, like description here, like the price, like the categories, and like the gallery. And this PHP API here, these PHP classes, are actually the way how we can interact and use all the data objects, all the data that is stored within the data objects in our application code.
Let's start with the data source, which is the first thing to be configured. There are a couple of data sources available out of the box, and so for example we can load the data from an SFTP source, where we also can specify things like host, like port, like username, password, and also the remote path of the file that we want to read and import. The next option we have is an HTTP resource. That means that we can download the data from an HTTP resource where we can specify the schema and also the URL. In this case, we also can encode username and password in this URL in order to access protected resources. Then we also have the possibility to define an asset as data source. So there we can just use a Pimcore asset, drag it there, and use this Pimcore asset as a data source for our import. Then we also have the possibility to upload a file directly in this configuration here. So we just open up the file selection dialog, choose a file from the local file system, and then use this file as the data source for the import. And then last but not least, we have this push data source. And while all the other data sources work with a file that is sent from A to B, the push data source provides an endpoint where the data can be sent to as an HTTP payload without writing a file somewhere. So there, Pimcore provides an endpoint and external systems can send and push the data to this endpoint. For all the data source types, the data needs to be structured in a certain format. And this format can be configured here in this format section. And again, we have a couple of formats available here. And depending on the format, there might be additional settings necessary. Like for example here for the CSV format, where we can configure to skip the first row and read the first row as column names. And in addition to that, we also can specify the delimiter, the enclosure, and the escape character. Then we have the JSON format available, which does not have any additional settings. And the JSON format expects an array of JSON objects and reads all the first level attributes of this JSON objects as separate fields for the data import. Then we have an Excel import available, where we again can specify the first row as columns and skip it from the actual import. And then we also need to specify this sheet name of the Excel file where the data is that we want to import. And then last but not least, we also have a XML import available or XML file format available. There we need to specify the XPath expression where we can find the data within this XML file. And then we expect a list of elements at this location of this XPath. And again, all the first level elements of this element list is then read as separate fields for the data import. If you need an additional data source or additional file formats, it's easily possible to extend the options with custom types and functionality for your custom needs. Of course, for this you would need a developer, but once set up by the developer, You can use this custom functionality in all your configurations for all your data imports. This also applies, of course, for all the other settings we will go through in the next sections.
Especially in context of data objects, Pimcore heavily utilizes the database. For example, when filtering for data objects, the queries are executed directly on the database. Therefore, database performance has huge impact on the overall performance of Pimcore. To optimize the database performance in context of the data objects, Pimcore allows you to define indices. There are two types of indices. There are indices on attribute level and there are compound indices on class level. Both of them are defined in the class definitions.
The attribute level indices are defined on the attributes themselves. So depending on the data type of the attribute, there is this indexed checkbox, and as soon as this is ticked, then the index for this column is created on the database. So let's have just a look at the store table, for example. And there we see we have two additional indices, one for the name column and another for some other number column. And the same also goes for the query table. There we also have these two additional indices now. If the indexed attributes are within more complex data types like the localized fields or like the field collections or like the object bricks, the indices are created on the corresponding database tables there. The combined or composite indices can be defined directly in the general settings of a class definition. Here in this composite indices section, where we can add multiple indices and there specify some key. We can select the table where we want to create the index on, and then we can select the columns that we want to have included in the index. And once stored, Pimcore applies these indices to the database table. And when we recheck, then we see we have an additional index here that contains all the columns we selected. Always keep in mind that indices also come with some cost in terms of storing and updating the data, but with these two options, defining attribute level indices and also this composite indices, Pimcore provides some great possibilities to optimize the database in terms of the data objects.
When creating or updating the class definitions, Pimcore not only creates and updates the PHP API, but also updates the database scheme. Normally, you shouldn't be in touch too much with the database, but there are still a few things you should know about the database scheme of Pimcore. Actually, there are two types of tables. First table type is created during the Pimcore install and don't change in structure. They are only used to put data into it. These are the tables like the assets table, the documents tables, the email tables, all the different tables that manage data except of the data object table. Because the data objects table are the second type of database tables, and these database tables are created and changed during runtime of Pimcore. Actually, every time a class definition is created, Pimcore at least creates three tables. A store table, object store with class ID, a relation table, object relations with class ID, and a query table, object query with class ID. The store table contains, as the name already suggests, all the store attributes. So all the data attributes that are actually not relations are managed in the store table. Well, actually not all, but most of the data attributes. When we have a look at the store table of our demo product category, we see that we have two columns in this case. We have an ID column and we have a name column. When we have a look at the store table of our demo product, we see we have a few more attributes. We have an ID column, and then we have a name column, a description column, a price column, and two gallery columns. There you can see that Pimcore tries to create a pretty readable and well-structured database scheme by creating a column for each data attribute a data object class has. So we have a name column, we have a description column, we have a price column, and so forth. Of course, for each object of a certain class, a row is created. When we have a look at the rows of our object store 9 class, which is the demo product category class, we see different demo product category objects and the values of the name that we have stored there. Besides the store table, we have the relations table, which contains all the relational data. The structure of the table is again fixed. It's not anyhow dynamic, and has of course the source ID, destination ID as columns, and a few additional columns that are needed to store the different relational data types in the different positions. When we have a look at the data, in this case, for example, we have a look at the data of our demo product, which has relations to the categories. We see for each relation one row in this relations table where we see from a certain product ID to a certain other product ID. The store table and the relation table are the primary data sources of all the data and are the data where Pimcore also reads the data from when it builds up the data objects and fills up the cache, for example. In addition to the store table and the relations table, there is the query table, which is not a primary data source, but more like a search index for querying the object data. When we have a look at the query table, for example, of our demo product, we see again we have all the columns for each attribute, but not only for the standard attributes, but also for the relational attributes. So Pimcore tries to serialize somehow the relational information into additional columns into the query table. In the case of the categories, that would be a CSV value, and this should enable some easier, simpler queries that of course are not so performant, but a bit easier to write. The more important reason for the query table is though that it also considers the data inheritance. Before we activated the data inheritance for the demo product category, and when we have a look at the store table of the demo product categories and the data, then we see that in the store table only the data that is actually stored at a certain object is stored and not the inherited data. In the query table though, it's always also stored the inherited data, which of course makes the query on certain elements much easier, because when I, for example, query for category 1, I would expect that I not only get the actually category 1 object, but also all the other data objects that inherit this value from. And this is the biggest difference between the store table and the query table, that the query table actually considers the data inheritance. When we create an object listing and make some kind of condition, like we did here in this controller, where we set condition and set price, in this case, should be bigger than some specific value, this condition is always applied to the query table. Well, more specifically, it's applied to a view, which is called object underline class ID, and this view is a join between the objects table, which contains all the meta information for the objects, like the ID, the parent ID, the key, the path, these kind of things, and the join of the object query table of the corresponding class. This is quite an important information because if you like to debug some conditions, you really can just execute your conditions on these views, and then you see what data is actually be returned from Pimcore. What is also important to know is that Pimcore tries to make sure that all the data is consistent, and yeah, it's not recommended to manually fiddle around in the database tables and update data somewhere, because the chance that you make some inconsistency into your data is pretty high. And so really just use the PHP API to get data into the system and don't put the data directly into the database.
Hello and welcome to another session of Pimcore Insights, Debugging Hints. It is a short session to give you an idea how to perform debugging on Pimcore application and how to gather information related to the application. First of all, let's have a look at where all the logs are generated on Pimcore. Pimcore basically uses the Symfony standards for logging, which means there is a var log directory where all the log files are generated. Most importantly, log files like dev logs, production logs, and staging logs. Pimcore uses the Symfony monolog logger with few channels, and you can configure your own channel handler however you like it. You can log to the file system, you can log to Logdash, or any other logging system to analyze and gather information. In addition to default logging files, there are few log files generated by Pimcore, like PHP log, we located at the same folder, which logs all the PHP errors. There is also a Pimcore specific log file, which is called usage log. It logs every request done within Pimcore backend admin. It logs the information like time of the request, user of the request, which user called which controller action, request parameters, and some more information. This sometimes give you useful information to debug the actions performed on Pimcore admin. So for use case, let's say you want to identify why the data disappeared in your application. So you can check in the logs if a user changed it or it is a data loss due to some migration. Since this usage log contains personal data, this might be a GDPR issue. And there is a possibility to turn off the usage logs by configuring disable usage statistics to true in config YAML file. In addition to the usage log, we have a redirect log, which logs all the redirects that Pimcore does for you. If you have certain redirects, then sometimes it's hard to identify when there is an infinite loop or why certain behavior appears. So this log can help you in debugging redirect behavior. In addition to the standard log files, there is a simple mechanism to write custom log files, which is sometimes quite useful. But also you can use Symfony monolog mechanism with custom channels. Another aspect of debugging Pimcore are so-called magic parameters that you can attach to every request, and they modify the default behavior of Pimcore. Most of these parameters can influence the behavior quite heavily and can cause performance issues. And that's the reason why they are only possible or active when debug mode is on, to prevent denial of service attacks and related issues. All these magic parameters are listed in the documentation, and these are magic parameters like deactivate the cache for a request, deactivate the output filters, and deliver unminified JS of admin backend. Pimcore log is a quite useful parameter, which allows you to log all the log messages which are generated during the request to a separate log file, which is sometimes quite useful for debugging. And then there are a few others like disable host redirect and debug translations. And there is of course the classic debugging, where you can perform server-side debugging with Xdebug, Symfony Profiler, and other standard tools that can be used for server-side debugging of PHP applications. And on the other side, client-side debugging, especially useful when you're developing extension for the Pimcore admin interface, where you can use the browser debugging tools and so on. Especially in combination with client-side debugging, it is quite useful to get the unminified JavaScripts. There are on one side is a magic parameter that we have already discussed, or you can just activate the dev mode by configuring the environment variable pimcore dev mode true, which delivers the unminified JavaScript for all the requests. In addition to server-side and client-side debugging, there are additional headers that Pimcore attaches to the request response that might help in debugging. We have already covered some in output cache session. There is one more which is X powered by Pimcore. This header is attached by Pimcore when a request is served by the Pimcore application. So if this header is not set, then you should look for issues at some other places other than Pimcore.
Hello and welcome to another session of Pimcore Insights. This time it's a really short one and it's all about deployment. The reason why it's really short is that there is not this one deployment solution for Pimcore. There are so many environments, technologies, workflows, and even philosophies when it comes to deployment, so that Pimcore doesn't want to force you in one specific deployment scenario. Pimcore provides, though, several tools and best practice suggestions when it comes to deployment. And these are summarized here in this documentation page and are, first of all, how to use version control systems, then second, multi-environment configuration, and a list of available deployment tools. In terms of the version control systems, we provide best practice Git ignore list, which you can use for your projects. Of course, you can adapt it to your specific needs if you want to. Pimcore is not overwriting this Git ignore when it's updating itself. The second thing is the multi-environment configuration, which is of course available for all the Symfony configuration files, where you can specify environment-specific overrides of certain configuration options. And in addition to the Symfony configuration files, you also can specify the Pimcore PHP configuration files that are around there with environment-specific settings. The difference between the Symfony configuration files and the Pimcore configuration files is that the Pimcore PHP configuration files do not support the inheritance model that the Symfony configuration file have. That means that once a specific file for a specific environment is found, it's the only one that is loaded and it needs to contain all the information. There is no inheritance model available there. Later or sooner, we are planning to move all the PHP configuration files of Pimcore to the Symfony configuration anyway. Setting up the environment is then again standard. So there are several options that are all documented here in the documentation, and you can choose the one that is the best for your use case and for your deployment scenario. And then there are these deployment tools, which are all available via the Pimcore console. And the most important, of course, is the Pimcore deployment classes rebuild command, which rebuilds all the tables and also the PHP API of your Pimcore data object class models based on the class definitions. In addition to this Pimcore deployment classes rebuild command, there are several additional potential useful commands that you can use and integrate into your custom deployment scenario, and use them or don't use them if you don't need them. Finally, one sentence to the topic of content migration or content deployment. Our approach here is to don't do it, don't deploy content from a dev stage or a staging stage to a production stage, because deploying content is always a big issue and a big challenge. We recommend to use the built-in features like publishing, unpublishing, versioning, scheduling, and preview of the Pimcore, especially the Pimcore documents, but also the Pimcore data objects. If you still need content deployment, then you need to create it for your own and utilize the PHP API for assets, objects, and documents, and create your content deployment scenario specific for your use case and your requirements. So far, we just used one document type, which always represents a complete web page or a complete page, which is actually called page. But besides the pages, Pimcore provides a couple of additional document types, which you can see here in the document context menu. First of all, the page, which again represents the complete page or one complete page and was used so far. In addition to the page, we have so-called snippets, which actually are a snippet of a page and part of a page that I want to reuse maybe multiple times. Typical examples for these snippets would be a sidebar like we have it here in our demo document, or even more likely a footer which I want to define once and then include on multiple documents. Of course, you always can follow these snippets, and this snippet is now just a part of a page where I can define a certain amount of content, and once I change the snippet, once I update the content of the snippet, then of course all the places where this snippet is used are updated immediately. So another example of single source publishing here. In addition to pages and snippets, we have links, which are actually just a link, and this link redirects to another page. And then we have email documents and also newsletter documents. Let's quickly just open up an email document here in our demo application, which is actually, again, just a default document which should be used when I want to send some transaction mails in my web application and still want to provide an editor some flexibility in terms of modifying the content of the email. Again, it's a typical Pimcore template with all the editables. You also can, of course, use area bricks and these kind of things here. And in addition to the default document functionality, you also can provide so-called placeholders, which then are replaced by actual values when this document is used for sending an email. Of course, the developer has to provide all the variables that the placeholders can be replaced correctly when sending the mail. In addition to the default settings and tabs, the mail documents have an additional tab which is called Send Mails. And this Send Mails tab actually lists all the mails that were sent based on this document, and you even have access to the actual HTML which was sent to the corresponding recipient. Similar to the email documents, there are newsletter documents, which are again just normal documents with all the editor functionality you already know, like editables, like area bricks, all these kind of things. And in addition to the Send Mails tab, the newsletter documents have this newsletter sending panel, where you can send a newsletter directly out of Pimcore based on a specific address source adapter, like for example just a simple CSV list with all the addresses a newsletter should be sent to, or for example also a thing like a default object listing or a custom report that provides you the addresses that should the newsletter go to. At this point, it should be mentioned that sending millions of mails directly out of Pimcore is maybe not the best idea, not only because of performance reasons, but also because of spam aspects in terms of using a certain mail server and these kind of things. So in this case, you really should think about, is it feasible for sending the newsletters directly out of Pimcore, or might it be better to just integrate to an external newsletter provider. In addition to the newsletter document, we have two more document types, one of which is hard link, which we will explain in a further session. And then, of course, I have the possibility to add folders, which are just the possibility to make additional structure in the tree. They don't have any functionality in terms of the output channels and the outside world. A quite common way of extending existing systems are events and event listeners. And so also Pimcore fires lots of events during runtime, which allow you to interact with the system, to modify the default behavior of the system, and of course to extend the system. Which events are fired is documented in the documentation under this available events section, where we linked all the different constants that define which events are fired during runtime. For example, in the context of data objects, we have events like pre-add, like post-add, like pre-update, post-update, delete. So all the standard events that you might expect in terms of handling with data entities, but we also have much more events that just are fired during runtime, like workflow events, like mailing events, like caching events, and these kind of things. The event dispatching itself is nothing that Pimcore reinvents. Pimcore uses the Symfony framework event dispatcher, and so it just fires events for this event dispatcher, and registering event listeners and handling these events is pretty much Symfony standard. To see how this is working, let's create an event listener that listens, for example, to an update event of a data object and does some validation or something like that. So every time we save an object, then we want to do some custom extension. And to do so, let's have a look at the data object events which are available there. And let's choose, for example, the post update event and create a listener for this post update event. There we see, okay, as the post update event gives us a data object event object to interact with the system. Now let's switch back to the IDE and create an event listener. And as event listeners are pretty much standard Symfony event listeners, let's create just an Academy event listener. And we don't need to extend any parent class or implement any interface. We just need to create a method which should be our event handler, for example, on update, and have this data object event as an event here. And in this function now we define our custom validation logic. For example, let's just check if the object is instance of, for example, our news class, then do some validation or external system interaction, or in our case we just throw an exception to see if it's working. And that's already all for our event listener. We have to do a second step though. We have to register this event listener into the Symfony container, and that can be done, for example, in the services YML, and actually in the services YML of our installation packages with the demo installations, we already have some example for how to register an event listener. And let's just copy this one and adapt this to our needs. We have an app bundle event listener, Academy event listener. And what needs to be done now is to assign this service additional tags for registering or making sure that they are listening for the desired events. And these tags always have to have the name kernel event listener. Then we have to specify the event that they should listen for. This event is the event we have here in our constants file. And then we have to specify the method that should be called in this class when the event is occurring and needs to be handled. And this is in our case the onUpdate method. Then we need to rebuild the Symfony container, of course, to make sure that the event listener is registered correctly. And then we go back to our Pimcore backend system and resave the data object. And we see now an exception is thrown with our message, and we have successfully registered an event listener on the post update event. This is not a very useful example in terms of functionality, but it should show quite easily and quite clearly how to implement event listeners and how to register the event listener and make sure that they are listening for the correct events of the Pimcore system. Let's have a look at the provided functionality of the customer management framework that you see in the Pimcore admin interface. Of course, it's a framework, and of course, you also have lots of functionality that you can just use in your application code. But back to the admin interface, first of all, we have, of course, the customers, which are Pimcore data objects, and the customers themselves can be quite flexible. The only thing that you need to make sure is that they implement certain interfaces so that the customer management framework can interact with the data objects. But other than the attributes that are required by the interface, you are completely free when it comes for data modeling, setting up additional fields, and all these kind of things. In this example, we have a quite simple customer data object, but of course, they can be much more complex and can have much more attributes and additional fields. Second thing are the activities. They are visualized here in an additional tab of the customer class, where you have a list of all the activities that are available for this certain customer. And these activities all have a certain type. So you, of course, can also filter for certain activity types, and there you also see additional information of the activities. There is also some kind of detail page for the activities, but this detail page is really basic by the default implementation and can be overridden by your custom implementations to provide nice looking activity detail pages if necessary. Then, in addition to customer data and activities, we have the segments. Segments, as we said already, are again just Pimcore data objects where we have customer segment groups and then the actual customer segments. The customer segments and segment groups as data object classes will be installed when installing the customer management framework, and they of course need to have some system attributes that need to be there, but also with the customer segments and the customer segment groups, you can extend them and add additional attributes, and again can use the full power of the data object engine of Pimcore. The assignment of segments to customers is done via standard Pimcore relations. Actually, it's a advanced many-to-many object relation where you have the segments assigned and where you have some additional optional metadata information, like when the first or the last segment assignment was done. This can be quite useful when it comes for cleaning up old segment information. And the second metadata information is a segment application counter, which allows you to count how often a segment is assigned to a customer, and this again gives you some options for separating between segments that are only assigned very few times and segments that are assigned multiple times. Also, we separate between manual segments that are assigned manually either by an editor in the user admin interface or by the user itself in some custom login area or whatsoever. And the second group are the calculated segments, which are, as the name already suggests, calculated by any kind of segment builder. Then, in addition to the data objects, there is a menu that provides some additional functionality of the customer management framework. First of all, the customer list, which is just a nice looking list for the data objects. Here you have some full text search functionality where you have the options to specify some additional filters on specific attributes and also on segments. You can freely configure which segments should be here as a filter option. You can save these filters, you can share these filters with other users, so similar to the grid configuration of, for example, of Pimcore. And then you have, of course, a list of all the results that match your condition criteria. These results can be exported with different formats. And of course, we also have, again, some kind of detail page, which is, again, really basic in the standard, but can be overwritten and can be customized to your specific needs. And of course, you always have the link to the data object itself, where you then can jump to the Pimcore data object standard object editor. Then we have the duplicate index, which has the user interface that provides you with potential duplicates. All the duplicate calculation, of course, is done asynchronously in the backend, but at some point, somebody has to decide whether a potential duplicate is really a duplicate or not. And this is what this interface is for, where it lists all the potential duplicates that are found, and the editor can then decide either to decline and tell the system that these are really actually two different persons, or the possibility to merge the customers to one and then archive the other customer. And last but not least, we have the customer automation rules, which are a possibility to define certain automation rules directly in the user interface. And yeah, let's just, for example, open up an existing one similar to the behavioral global targeting rules. You have again some meta information like name, like description, like whether it's active or not. Then you can specify certain triggers when this rule should be executed. For example, every time when a new customer activity is tracked for a certain customer, then this rule should be executed. There are other triggers like cron, like segment building process, and other things that also can act as triggers. Of course, you also can extend this list of triggers with your custom implementations. Next up, we have conditions that you can specify that need to be applied before the action is then executed. For example, when an activity is tracked, then we also want to check the count of a certain activity type. So check how many order activities, in this case, for example, a certain user has already tracked, and only then execute a certain action. Of course, again, many different kind of conditions, and also the possibility to extend these conditions with additional custom conditions. And then we have the actions, which should be applied when the trigger is, the trigger executes the automation rule and the conditions apply. And in this case, we assign a segment to the corresponding customer, but of course there are again different actions that can be executed. So just to summarize, what this rule actually does is it checks every time a customer order activity is tracked, how many customer order activities are already tracked for this corresponding customer, and only when there are more than 3 orders, then the customer gets assigned the VIP customer segment, so that I know this is a very regular customer that orders a lot in my application.
Assigning target groups to customer data objects can be done in multiple ways. In combination with the customer management framework, we suggest the following way, which is via customer segments. Customer segments have a special option which is called Use as Target Group, and as soon as you activate this checkbox, there is a link created between the target group and the customer segment data object. Actually, as soon as you activate this checkbox, Pimcore creates in the background a corresponding target group. As an alternative, you also can link the target group manually by just selecting here an existing target group. As soon as you have linked the customer segment to a target group, you have some kind of 2 types of customer segments. You have the fine-grained normal customer segments that describe all the aspects of a customer, and then you have this high-level target group customer segments that are linked to a target group. But since they are also just normal customer segments, you can use all the existing functionality of assigning these customer segments to the customer data objects and extracting it and all these kind of things. As soon as you have set up the customer segment target groups, you can use them to either, of course, assign target groups that are assigned by the targeting engine also to the customer data objects, and you also can use them to do it the other way around. That means that you can initialize the targeting engine based on the segments that are assigned to a customer that has logged in to the system. Let's start with the first way, so assigning target groups that are assigned by the targeting engine to a customer data object, and this can be done with global targeting rules. There is one example already there, which is the economy car fan targeting rule, and actually there are a couple of conditions, but the most interesting part is the assign target group action here, and this assign target group action is extended as soon as you install the CMF with additional options. Actually, the last 3 options here are CMF specific. And with the first option here, you can specify if the target group that is assigned to the visitor info in this case should also be assigned to the customer object if a customer is logged in. And then, of course, it's using the linked customer segment and assigns it to the customer object, either just assign it or also considers the weight and increases the application counter. In addition to assigning the customer segment, you also can specify if we should track a customer activity and if we should consider the profiling consent of the current customer. And with this simple addition to the standard assign target group rule, you also can always assign the target groups or the target group segments to the customer data objects as soon as a target group is assigned in the profiling engine of Pimcore. And now we also need it the other way around. That means we want to initialize the Pimcore targeting engine based on the target groups or the customer segments that are assigned to a customer data object when this customer logs in into the system. And this can be done with another global targeting rule, which is called here init target rules. And there we just have the condition, of course, that the customer is logged in. And then we have a special action again which ships with the customer management framework, which is called CMF Applied Target Groups from Assigned Customer Segments. And there you can select certain target groups, and once the user then logs in, the system checks if the customer has assigned the corresponding customer segments, and if so, then they are assigned to the current visitor info. And then we have there an additional option where we can specify whether it should clean up the existing target groups, if it should merge them and clean up, or if it should only merge the target group with the existing ones that are already in the visitor info of the current visitor. And that's again already about it. With the simple checkbox here, use as target group for certain customer segments, and with these two kinds of global targeting rules, you can combine the two worlds of the anonymous users of the targeting engine and the logged in users of the customer management framework.
Next, we need to discuss how we further can connect the two worlds of the targeting engine on the one side and the customer management framework on the other side. As you maybe already noticed, the targeting engine mostly deals with the anonymous users and tries to profile them, while on the other side, the customer management framework deals with the known customer, where we have a customer object and where most likely the customer is logged in into the system. There are now two aspects how we further can connect these two worlds. The first aspect are the tracked segments, which are tracked by the targeting engine and that we want to store in the customer object. And the second aspect are the target groups, which we also want to store in the customer object. Let's start with the tracked segments.
The tracked segments can be assigned to the customer data object with custom automation rules. And in our demo application, we have again an example for that. First of all, we need to use a trigger, which is the segment tracked trigger. So it fires every time a segment is tracked in the targeting engine. Then we optionally can add a condition. For example, we can check for the count of the tracked segments, and we also can filter for the segments so that not every segment is used for the action, but only if certain segments are tracked. And then there is a special action which is called add tracked segment. And this action uses the segment that is tracked, which caused the trigger to fire, and then this segment is assigned to the customer if a customer is logged in and available. There are a couple of additional options there. First of all, we can remove the other segments of the selected segment group. Then we can increase the application counter of the segment if it's already assigned. And we also can again check if the customer has consent to the profiling. And that's already about it. With this simple rule, you can assign the tracked segments to the currently logged in customer data object. Besides these custom automation rules, you always, of course, also can use your custom code and assign the segments to a customer data object with your custom controller implementation, with your custom services. So this is also, of course, always an option to do this.
Hello and welcome to another session of Pimcore Insights. This time it's all about the e-commerce framework. The e-commerce framework makes Pimcore an experience and commerce platform that allows you to create any kind of commerce experiences with one system only. It of course integrates with all the Pimcore modules like the master data management, the digital asset management, and the enterprise content management, and puts all the bits and pieces together. It also follows the Pimcore principle of being a framework rather than a ready-made system. And that means, of course, great flexibility, but also as a consequence, you need a developer to get started. But let's have a look at the generic overview of the e-commerce framework first. Before we started with the e-commerce framework, we used many different other e-commerce systems to create e-commerce solutions for our customers. But we faced challenges that made our lives really hard, and these challenges were things like complex product structures, complex pricing structures, complex availability calculations, thousands of customers with individual prices each, individual workflows, individual designs, and highly agile customers. Actually, we came to a situation where technology was not a cost center anymore, it was more like a enabler and key asset. And we needed flexibility, integration, we needed time to market. Actually, we needed a toolkit for developers to build outstanding e-commerce applications. And with this toolkit, with this framework approach, we are not alone anymore. Many others, like Spryker, like Orocommerce, Commerce Tools, Shopware, and others, are now going into a similar direction when it comes for e-commerce solutions. So, what is the philosophy of our e-commerce framework? It's a framework for developers to build outstanding e-commerce solutions for their customers. It has, of course, a native integration into Pimcore, and it has a component-based architecture, which means there is a strict separation between backend functionality and the front-end presentation. Actually, the framework only provides the backend functionality. There is, similar to all the other Pimcore modules, there is no ready-made front-end presentation available. The target group for the e-commerce framework are businesses who want to present the USP in the digital world, who need agility and speed for trial and error, who have unique products, services, or processes, and really want to stay ahead and present their unique selling propositions to the outside world. When you build a solution with the framework provides you with an architecture, with a structure of e-commerce application. It provides you with services and components for common use cases and common functionality, and there is also some kind of blueprint available for best practice implementations. You need to provide all the design, all the front end, all the views, all the controllers. You can specify all the data models. You have complete flexibility there, as all the data models like products, product categories, these kind of things are simply Pimcore data objects. And of course, you also can provide custom extensions wherever they're necessary. The big picture of the system is that there are several modules like index service, filter service, tracking manager, price and availability systems, tax manager, multi-tenant functionalities, pricing manager, voucher systems, and so on and so on. And with these modules, you can build your solutions with Pimcore to provide e-commerce use cases, e-commerce solutions like individual omnichannel use cases, B2C use cases, B2B use cases, marketplace use cases, content commerce functionality, product finders, and so on and so on. So actually there are no limits what you can create with the e-commerce framework and Pimcore. Before we have a more detailed look into the framework itself, let's have a look at a few showcases to see what can be done with the framework. First showcase is Frischeis. We saw them already at the beginning, at the first course. And yeah, there we have created a multi-tenant, multi-country B2B shop system with lots of additional tools, with about 250,000 products and 10,000 customers. And each of these customers have customer-specific prices and assortments. So this is a quite complex use case there. We have also, of course, integrated external systems, like in this case, the Floor Studio, where you get all product data, of course, out of Pimcore, but where you can then render in an external tool how a room would look like when you use a certain floor. And once you have decided yourself for one specific floor, for one specific product, then you can put back this product into the shopping cart of the e-commerce application and then order and finish the checkout process. Another use case is now a B2C use case, a really simple brand site where you have a simple product catalog that is presented. And in addition to the standard products, there is also an integrated configurator for custom products, in this case for team sport tricots, like football tricots or handball tricots. And these configurator allows you to create completely custom designed tricots and also allows you to order these tricots. A third use case is now a completely different in terms of the process itself. It's not a classic e-commerce in terms of buying stuff. It's a rental use case where B2B ski and bike rental is implemented for Intersport Rent. It has integrated over 310 different locations with individual products, individual seasons, individual prices each. Has a quite sophisticated search integrated in terms of how to find the locations, also with different other search terms like poise, even ski lifts. And the system also has a quite extensive database of customers in behind, and also have a really shortened checkout workflow, because for especially ski rental products you normally need a lot of information of the customer, like his height, his weight, his shoe size and these kind of things, which of course makes the checkout workflow quite complex, because you need to ask for all this information, and as we all know, complex checkout workflows reduce the conversion rate. And that's the reason why we decided for this system to really shorten up the checkout workflow, to make the customer conversion really easy. And then after the conversion, after the checkout is completed, there is an additional data collection workflow where we ask the customer for all the additional information that is needed to prepare the rental equipment. An even other use case is ishkel.com, which is a hotel booking application and extensive hotel search with best price calculation, with corridor search, with different package deals. So really a completely different use case. And again, also for this use case, the e-commerce framework is the foundation. And these use cases should show you the wide range of different solutions that can be built with the e-commerce framework. Hello and welcome to another session of Pimcore Insights. This time it's all about customer data management. Pimcore is really powerful in terms of managing any kind of data and in terms of delivering digital experiences to users. With the e-commerce framework, Pimcore also has the power to implement any kind of commerce application. But what's missing so far is the customer. Of course, you can use the data objects for managing customer data, but there is more to that topic. And this is where the customer management framework comes into play. The customer management framework is an extension of Pimcore that has two big areas of functionality. Similar to the Pimcore itself, we have the master data management of customer data in terms of the data management, and we have personalization and marketing automation in terms of the experience management. The customer data management has three big areas. First of all, of course, the management of customer data itself, which is based on Pimcore data objects. And this means, of course, that you have the full flexibility, the full power of the whole data object engine of Pimcore to set up your data model for the customer data, and of course also to use all the functionality, all the APIs, and all the options that the data objects provide. In addition to the data objects, for customer data, the customer management framework provides activities and triggers to store any kind of interactions that a user does with your systems or with you as an organization in general. That means activities can be creating a user account, logging in into your system, or registering for a newsletter, or doing any other kind of interaction with you and your systems, like, for example, placing an e-commerce order. These activities then can be used as triggers for any kind of marketing automation and personalization. And the third big area of the customer data management is the customer segmentation, which allows you, as the name already suggests, to segment customers into separate groups based on their interests, based on their behavior, based on whatever criteria you define, and use these groups then for personalized marketing activities. The experience management part of the customer management framework again has three big areas. First of all, we have the personalization, which is based on the personalization and behavioral targeting engine of Pimcore and extends this Pimcore engine to the logged in users. So you can also personalize for your logged in user. You can initiate the behavioral targeting engine based on the data that is already stored in the customer profiles. And of course, you can use the customer segmentation information for personalize the content that is provided to the users. The second big part is the marketing automation, which is right now mainly newsletter and mailing automations. And for that, Pimcore integrates into MailChimp and IBM Marketing Cloud, and also to other systems that provide marketing automation, and delivers the templates for the newsletters, the personalized templates to these platforms, and also, of course, all the necessary user information and segmentation information. And the third area of the experience management is the customer profile, which is a customer login area with additional functionality. In this case, it's also not a ready-made product, but more a set of tools and functionalities and modules that you can use to set up your custom login area with connection to social logins and using single sign-on to Google, Facebook, Twitter, and so on, where you can show the personal data of the users, is orders, reservations, and of course any kind of personalized content. Hello and welcome to another session of Pimcore Insights. This time it's all about personalization and behavioral targeting. You maybe already know that Pimcore ships with a full-featured personalization and behavioral targeting engine that allows you to create personalized experiences directly with Pimcore Experience Manager. To do so, you need to follow following 4 steps. First step is to define target groups. While Pimcore also supports one-on-one personalization, it turns out that target groups come in especially handy when it comes to creating personalized content and a good experience for your visitors. Second step is to create so-called profiling rules, which define which behavior a certain user has to have in order to be assigned to a certain target group. Third step is then to create the personalized content for all the defined target groups. And the fourth step is then finally to deliver the personalized content to the correct visitors. So much for the theory. Let's have a look into Pimcore backend and see how these 4 steps are fulfilled with Pimcore. Once you have logged in into Pimcore backend, you need to do the first step, which is actually creating target groups. This can be done in the marketing menu, personalization, targeting, and here target groups. Let's say we want to create personalized content for outdoor loving visitors within our e-commerce demo shop, and we want to give them a special welcome and a special experience. To do so, first step is to create a target group. So let's just create an outdoor lover target group, and within Pimcore a target group is a quite simple entity that has a name, can have a description, can be active or not, and also has a threshold. For now we ignore the threshold, we will discuss this in later session. So from the technical perspective, this target group is quite simple. It's just an entity that is referenced then on multiple different places within the system, but not much more. In terms of the conception and the concept for creating personalized experiences, the target groups are quite crucial, and it's quite a big task to define all the target groups that you want to personalize for. But for now, first step is finished and we have created our target group. Second step then is to create the profiling rules, which can be created with the Pimcore global targeting rules. And yeah, let's just create such a profiling rule. Let's call it profiling outdoor lover. And again, these global targeting rules can have a name, can have a description, can be active or not, and also have an action scope. Also, this action scope is now out of scope for us. We will discuss this in later sessions. In addition to the basic settings, the global targeting rules can also have conditions. And these conditions can be composed from many different criteria like browser, country, geographic information, or language, operating system, or special time on site, special URLs that the visitor has to visit. Lot of different possibilities. If these possibilities should not be enough for you, you always can add additional criteria here to this list. Let's define a quite simple condition. For example, let's say our visitor has to have Google Chrome as a browser and also has to visit a specific area of our website where we then think he might be interested in outdoor stuff. And this special area is, of course, the outdoor area of our demo e-commerce shop. So let's just get this URL part here and define a regex based on this URL part and say this is our condition that needs to be fulfilled, that a visitor should be assigned to our outdoor lover target group. And this assignment can be done with the actions of the global targeting rules. And there we now just add this assign target group action and say, okay, we want to assign the outdoor lover target group to our visitor once the condition is valid. And then that's about it for defining profiling rules. So save this rule and we have completed our second step, which is defining the profiling rules. The third step was then to define the personalized content. And this can, for example, be done directly within Pimcore documents. Let's, for example, just open up our portal page and say we want to create a specific variant of this portal page for our outdoor loving visitors. Once you have defined certain target group within your Pimcore backend system, you have an additional menu here in the bottom left corner of the edit mode, which allows you to select a certain target group. And once you select this target group, then Pimcore loads the personalized variant of the current document for this selected target group. So now we have our outdoor lover variant, and let's say we want to maybe add just an additional headline here. So let's say hello outdoor lover, for example. Let's just center this and make an H1 out of it. In addition to the headline, we maybe also want to offer different products to our customers. So let's also override these teasers here and go to our Pimcore products here, products, outdoor products, of course. And let's say we want to assign a jacket here and then maybe another jacket. And let's say maybe we also want to add some shoes and maybe let's add an additional rucksack here so that it's really a nice selection of products we want to offer our outdoor lovers. Saving document, job done, third step, finished. We have created personalized content. Fourth step then is to deliver the personalized content. And the good thing about the fourth step is that Pimcore takes care about it. You don't need to take care about delivering the correct content to the correct target groups. So basically we have set up all the things already. Let's test them. And for testing them, Pimcore also provides us some functionality that we can test this stuff more in detail. And one of these functionalities is the targeting toolbar. This can be also activated directly within the Pimcore backend. And once this is activated and we are going back to the front end, Pimcore loads this targeting toolbar here on the right corner, which provides us two functionalities. First of all, it shows us all the information that is available of the current visitor. Right now we are quite a new visitor, so there is no information available yet. And the second functionality that this targeting toolbar provides is to define so-called overrides, where I can test how would the website behave if I were a certain target group. And let's do this for now. So let's define that we are the outdoor lover, apply this, and now we would expect that Pimcore delivers us the outdoor lover specific content. And tada, there it is. We have our headline here, and we scroll a bit down, we see all the different products that we have defined for the outdoor lover target group. So this works quite well. Pimcore delivers the correct content for a specific target group. So let's reset that again and let's test the second step, or the second thing, if our profiling rule works as expected. And for that, let's just open up the outdoor section of our shop and have again a look at our targeting toolbar. And there we see already two additional things now. First of all, we see that now there is a matching rule, which we defined. Actually, it's our profiling outdoor lover rule, which is good because we defined once a Chrome browser visitor visits the outdoor area of our shop, our profiling outdoor lover rule should apply and matches. So this matches here, which is good. And we also see that now the current visitor has assigned a certain target group, which is the outdoor lover target group because of our matching rule here above here. We also see a certain weight, which is actually a count how often this target group is assigned to the user. So when we, for example, filter here a bit and surf in this page here, then we see again the matching, the rule of outdoor lover is matching here, and the assigned target group outdoor lover is now increased in terms of the weight. So the target group is assigned multiple times. So second thing also works. Our profiling rule is configured the correct way, and we see how the information for the current visitor is available here in the targeting toolbar. So, and for the final step, let's go back and see if the automatic deliverance of the personalized content also works correctly. So when we go back to the portal page, now we would expect that Pimcore delivers us the content for the outdoor lover. And let's open up the portal page, and there we see it's the auto lava content again, where we have all the products that we defined before and also the headline above. In addition to that, we again see in the targeting toolbar that first of all, we have still the target group assigned, of course, and we also see some information about which target group is used by Pimcore to deliver the personalized content. In this case, for the document EN, Pimcore uses the outdoor lava target group to deliver the personalized content. This is quite handy when it comes to the situation that a visitor has multiple target groups assigned. Here, in this case, Pimcore would select the target group with the biggest weight and uses this target group for delivering the target group specific variant of the certain documents. And with this information, then you can verify and see which target group was used for delivering the content. And that's pretty much about it. We have created a personalized experience, quite a simple one for now, but it should wrap up the functionality quite good. In the next session, we have a look at e-commerce functionality and how we can combine the personalization functionality with the e-commerce functionality from Pimcore. So see you there. Bye-bye.
Hello and welcome to this session of Pimcore Insights. This time it's all about the simple file export adapter of DataHub. Maybe it's just me, but I have the feeling that one of the most common interface technologies still is the file exchange, especially for loosely coupled systems. The simple file export adapter empowers the DataHub to export data into files on a regular basis. It is not a replacement for the ad hoc export feature of the Pimcore Data Object Grid, but it provides similar possibilities in terms of setting up the output schema. Let's have a look at the configuration.
Simple file export configurations can be added as any other configuration to DataHub, and they're also following the typical configuration way of DataHub. That means we have some general settings like activating the configuration or adding a description to it. Then we have the schema definition, and there it's important to know that the simple file export creates flat files. That means flat CSV files, flat XML files, or flat JSON files. And so at this point we need to flatten out the Pimcore data model to have a flat result. This can be done by selecting a data object class here and configuring a schema for it. And the schema configuration is the same as we are using for the data object grid, where we have a similar challenge. Also there we need some flat data, and there we can add data attributes and also add a couple of operators like extractors, like formatters and these kind of things to extract more complex data of Pimcore data objects and flatten the information out in the result. Then we also can specify image thumbnails and video thumbnails that should be used for generating the information for the assets that might be linked to the data object. The next step then is to define a workspace, which is the typical DataHub way again, where we just add certain folders we want to include in the export. The next step is trigger for delivery, where we can specify when the file creation should be triggered. There we have a couple of options like never do it automatically and just do it by a command that it's executed in the background. Always do it directly when a data object is saved, or populate to a queue when a data object is saved and then run a background process that processes this queue and creates the export. We have a more detailed discussion about these options in a later session. And then last but not least, we can specify the delivery destination. That means we can specify the file type we want to export to, and then also the actually destination where we want to export to, like a local directory or some remote location.
Hello and welcome to this session of Pimcore Insights. This time it's all about the simple REST endpoint of the DataHub. The primary technology of DataHub was GraphQL. GraphQL is really powerful, very flexible, and supports all the different possibilities of the Pimcore data model. Therefore, it also remains the primary technology for the data hub. But sometimes you don't need all this flexibility. Sometimes a good old simple REST endpoint is the way to go, especially when you just want to list always the same data. And this is what the REST endpoint is for. It allows you to define simple REST endpoints and integrate them, for example, into a front-end application. One special thing about the simple REST endpoint is that all the data that is delivered directly is delivered out of Elasticsearch instead of the Pimcore database. Therefore, it really scales and performs very good. This is how the configuration looks like.
Simple REST API configurations can be added as any other configuration to the Data Hub config, and they also follow the typical Data Hub configuration scheme. That means we have a couple of general settings like activating the endpoint or adding additional descriptions to it. Then we have the schema definition that defines exactly what data attributes should be exposed via the endpoint. There we have first of all the option to add multiple data object classes. And for every data object class, we can define the schema by exactly defining what data attribute should be added to it. Here we reuse the grid configuration dialog we know from the data object grids. And so we have the possibility to add all the data attributes here. And we also have the possibility to use operators like extractors, formaters, transformers, and others to further extract more complex data types of the data model of Pimcore, or do simple transformations like uppercasing or combining two attributes and these kind of things. In addition to the data objects, we also have the possibility to include the assets to the endpoint. That means that the endpoint also allows searching for assets. And for images, we have the possibility to set if we want to deliver the original images and if we want to additionally deliver certain thumbnails of the images. Next are the workspaces that we can define in the typical Pimcore way, where we just use the folders and define there what elements should be exposed via the endpoint. And there we have, first of all, of course, the option to add folders and include them to the endpoint. And then we also have the possibility to exclude certain folders. The example here shows that we have the sample content folder that is included with all its children, and then we specifically exclude the dev examples folder by just removing this read permission here for these dev example folders. Then we have the label settings, which allow us to define nice names for all the data attributes that are exposed via the endpoint. There we have all the metadata attributes of the assets and also all the attributes that we defined in the data objects. And in addition to the nice names, we also can define here which attributes should be added to the aggregations. More on that in a later session. And then last but not least, we have the delivery settings, where we can define an API key that needs to be used when accessing the data via the endpoint here. And yeah, then we can save the endpoint and we have created a REST API for Pimcore. This REST API then has 3 calls available: this tree item call, this search call, and a get element by ID call. And in addition to these 3 calls, we also have a Swagger UI available where we can open the endpoint and test it right away, so we can see what we have configured, what data is returned, and so we get a good test possibility for the endpoint.
Hello and welcome to this session of Pimcore Insights. This time it's all about the direct edit feature of Pimcore. The direct edit feature of Pimcore allows you to improve the process of updating the binary data of an asset. That means it helps you to download the asset, opens it up in your preferred local editor, and after you saved the changes, it loads them back up to Pimcore and allows you to apply the changes directly to the asset itself. The easiest way of explaining the workflow is to showing it, and so let's have a look at it.
Let's start with opening an asset. And when you have installed the direct edit feature, we have an additional button here which is called Open to Edit Locally. and clicking on this button does exactly that. It downloads the asset, opens your local editor. In this case, I use Microsoft Paint because I love Microsoft Paint. Well, kind of. Let's do some changes here, for example, wiping out the number plate, and then we save the changes. In the background now, the changes are uploaded back to Pimcore, and as soon as they are uploaded, we can apply them to the asset. And then, as soon as we do that, Pimcore creates a new version, calculates all the previews again, and we have our new version of the asset available as soon as Pimcore reloads the asset then. We see our changes here in the preview, and we also see that it created a version for us so that we can follow all the changes that we did. Because this is so nice, let's do it once more and use an Excel document. Again, we click on Open to Edit Locally, download the asset, open Excel, then we do some changes. For example, let's change the headline here, and we save the changes. Again, Pimcore uploads the changes back, and we can confirm then they are applied to the asset, new version is generated, and then Pimcore reloads the asset, and we see the changes also already in the preview.
Hello and welcome to this session of Pimcore Insights. This time it's all about the enterprise asset metadata. First of all, it's important to know that the enterprise asset metadata do not replace the standard asset metadata. The standard asset metadata stay as they are, and the enterprise asset metadata are an addition that is built on top of them. They add additional data types, like for example many-to-many relation, like multi-selection, like calculated values and others. And they also add the possibility to define so-called metadata collections. Metadata collections are a set of metadata attributes, and they also define a certain layout for managing these attributes. They are similar to the data object bricks, if you like so. Let's have a look how they work in action.
First of all, we need to define the collections, and this can be done with the asset metadata class definitions here. And they follow pretty much the same principle as the class definitions and the object brick definitions do. So we can add an additional collection here, and the definition of the collection then contains again two things. First of all, we can define the layout of the editor for this collection here. So we can choose from different layout components, pretty much the same layout components as we have available for the data objects. And then second, we can define all the data attributes that we want to have in this collection here. And again, there we can choose from different data types, not as many as we have for the data objects, but still a nice collection of different data types that allow us to define quite extensive and sophisticated metadata definitions for our assets. Let's maybe just add a simple text field here. We also have the possibility, for example, for text fields to define if they are mandatory or not. And as soon as we save the definitions here for the collections, we can add these collections to our assets. And this looks like follows. So we have there our custom metadata tab, and there we see already it looks a bit different. We have there the possibility to select from all the collections that are defined in the system, and there we can add all these collections we want to add, and also define all the content in there. And as soon as we save the asset, then of course also the asset data is saved. What we also see here is that the enterprise metadata are built on top of the standard asset metadata, and we also still have this standard asset metadata grid for all the data. And there we also see that first of all, the enterprise metadata use the same technology and the same principles for the persistence. So they are just added to the standard asset metadata with a special naming scheme where we have this prefix, dot, and attribute name notation here. And what we also have is that we still can add freestyle attributes directly here in this grid and add additional metadata to the asset. And then last but not least, we also have the possibility to add or manage these metadata attributes in the asset grid. So there we can open up the grid options here. We have a list of all the different collections for the metadata and can add these attributes to our grid definition. And there we have the content then in our grid. We can filter for the content, of course, and we also can inline update the content and add the content directly here in the grid.
Hello and welcome to this session of Pimcore Insights. This time it's all about the Statistics Explorer. Often there is the requirement to provide certain statistics in an application and also to allow the user to play around and dig into the data a bit. And that's what the Statistics Explorer is all about. It allows you to create statistics, allow the users to play around with it, to dig into the data, do some simple data mining and get a better understanding of the data. It is also possible to provide predefined statistics, but it's not a real replacement for proper statistics and data mining tools. Let's have a look how it looks like in action.
The Statistics Explorer can be integrated into any host application. So, for example, we have it integrated into our experience portals. Once opened, you just can jump right into the data by selecting a data source. For example, let's just select the assets here as a data source. And then we have a couple of settings to specify our report. First of all, we can choose between two modes, a statistic mode that allows us to define aggregations and pivot tables, and a list mode that just creates simple result lists. Then we can specify rows and columns and select from all the different attributes that are available in the data source. Let's maybe create a simple report that has a look at our different types of the assets. And there we already have our first report and result. We have all the different asset types and the count of these types. Then we can filter down the results by adding additional filters. Again, select from different attributes here. And let's maybe just quickly select the type again and filter down to video. And our result is reduced to just the video entry. Then we can also specify the field settings for all the fields we have selected for rows and columns. So for example, we can change the order of the results and set it to count descending. And so now the image is the first entry here because it has 323 entries. And last but not least, we also can specify a visualization. So for example, let's quickly just create the pie chart, and there we have a nice looking chart with all the overview of the different asset types. Let's maybe do one more report. Let's just use the cars here and say we want to get an overview of the different countries and maybe see what colors the different countries or the cars of the different countries have here. So we easily have created a pivot table. Maybe let's also have a look at the different classes of the car here. So we really can easily create very complex pivot tables. And of course, also for these, we can create some visualizations. For example, let's just create a line chart or maybe a bar chart. It's better for this kind of report to see all the different results. Or one more example here, where we just have a look at the portal logins, which is an event that is tracked. Again, we define the rows. In this case, we use the timestamp because we just want to get an overview how many logins took place at different dates. And there we now can have a look at the field settings, where we have for the timestamp field now a couple of them, because the field settings are depending on the type of the data attribute. And in this case, we can choose from different settings that allows us the Elasticsearch aggregation. And there, for example, we can specify the interval, and let's say we set it for week. And tada, we now get all the different logins for a certain week. We of course also can do it per day. Then we have it really on a daily basis, how many logins we have into the portal. And then we of course also can again create a chart. In this case, maybe a line chart is the best choice. And we easily have created a chart that lists us all the different logins per day. Or let's maybe just reduce it again to week. And there we have a nice chart. And last but not least, we also have the possibility to save our reports and share it with different users and different roles. And of course, we also can load existing ones later on, where we then can continue our work or see the results of a report at a later point in time.
Now you are familiar with Data Hub concept, let's move on to next topic, getting started with Data Hub. It is important to know that Data Hub is an open source bundle. However, it is not a part of Pimcore default distribution. That means you need to install Data Hub plugin to use it. It is available on GitHub repository pimcore/data-hub. Let's have a look. Here you will find the documentation in the README section. In this documentation, you will find the information related to installation, configurations, and some examples based on Pimcore demo data. Now let's discuss about installation process. The only and important requirement for Data Hub installation is that it is supported only on Pimcore version 5.7 or higher. That means you need to update Pimcore if you're using any version lower than 5.7 before you install Data Hub plugin. To install Data Hub, you need to run composer require command, which downloads the package for you. After composer is done, you need to install and enable the bundle by running composer command for Pimcore bundles or by using extension manager in Pimcore admin. And that's it. You're ready to use Data Hub under menu options settings, Data Hub config.
Hello, my name is Andreas. I'm one of the founders of CI Hub, and it's amazing to be here at the Pimcore Inspire. This is really great to have the opportunity to show all of you a new way and a cool way on how we can access Pimcore data within your Adobe products or within your Microsoft products. And it's the whole range already. In the Adobe products, we have the InDesign, Photoshop, Illustrator, After Effects, Premiere Pro, and InCopy. And for the Microsoft products, it's PowerPoint, it's Excel, it's Outlook, and Word. So let me show you on how it looks on the CI Hub side. You've already seen how easy it is to set it up on the Pimcore side, and it's the same easy way on the CI Hub side. To create a connection, let me show you it in my preferred Adobe InDesign application. To connect to the prepared Pimcore system, you just go to the tab Connections. You click on Add a new connection. You click on the Pimcore button. It brings you to the login site. You enter your token. And that's it. If we go back to InDesign, there is our Pimcore connection. And it's a full connection based on your individual user rights. And now I select my Pimcore in the navigation, and I can start navigate within my Pimcore system. You see immediately if I have selected my Pimcore, I see my folders, I see the assets, I see the objects. I can now go into assets. I see the different subfolders. I go to car images, I go to Lamborghini, and I see everything what is available in the folders assets in my images from Lamborghini. To make it easy for you to navigate within the content, you see these images as a light table. You can see all the results as a list, or you can see the details of one of the selected assets, or you can just double click on it. Whatever it's more comfortable for you in your work process, this is already supported. If you double clicked on an asset, then you immediately see the basic metadata. We do support the custom metadata. So whatever you have defined in the Pimcore system, it will be showing up under custom. And you see the standard XMP, EXIF, and IPTC data. If you now like to use that asset, you can easily drag and drop that asset into your InDesign document in this case, or you can click on the download file dialog button, And you can even select the different renditions. Whatever renditions your system supports, this is a dynamic list and will be available immediately. So I would like to use that image, I drag and drop it, and I place it within my InDesign. Very simple. But I cannot just use my images and drag and drop them. I can also use metadata for this. And this is particularly interesting if I go to my objects, and within my objects, let me go within my assets. Within my objects. Let me go to the news area. Here I see all objects related to news. I click on the historic racing of Le Mans. Now I see a couple of assets which are related to that object, and I can drag and drop that text into my InDesign document as well. And I can use this one, I can use that image here and place it. You see, it's very, very simple. All the other functionalities which are available within our CI Hub plugin, like the similarity search, is also completely available to you in here. But you can not just navigate through your folder structure, you can also do the full text search. Let me type in Lamborghini. I should use something simpler. Here it is. Find all assets which are related to the Miura, and you see you also get all the filters which are available in your system, and you now can filter in a very easy way between all the different found assets and the objects. Very simple to do that. Let us use this one again. Let us drag it in here and use the metadata which comes with it. Let us use this one. There is a small disclaimer down here. Very simple. If you think that you have seen that image too often, just click on the similarity search button and tell the system, I would like to find a similar image within my Adobe stock system. And it immediately gives you access with the similarity search to all of the assets which are similar to the selected one in Adobe stock. You can also drag and drop it, you can purchase it, and if you're finished, you can upload the whole InDesign document and the assets back to the Pimcore system. One more thing, it is very easy to use it in the Adobe products, and it's even more easier to use it in the Microsoft products. Same here, you have your CI plugin, I'm already connected to my Pimcore system. I can navigate through my structure, I can drag and drop text into my document in here, and I can drag and drop my images in here. And I can easily design a wonderful flyer, brochure, sales folder, whatever you need. You see, we have put a lot of effort in it to make it easy for you and your customers to use the data within the Pimcore system in a whole new way, in a very simple way, in a way that almost needs no configuration, and in a way that allows you to open the Pimcore data to completely new user groups. And we think this is a big step for everyone to use the PIM data in a more easy and versatile way. I hope you like that. We do have a deep dive session in the afternoon. I hope you like to join that and ask as many questions, and I do a deep dive demo and give you all the details I couldn't do in this demo. So thanks a lot. Enjoy the rest of the day, and happy to get questions. Bye-bye. Thanks to all of you.
Hello and welcome to this session of Pimcore Insights. This time it's all about the product sub integration. The product sub integration is a huge thing for Pimcore, as it opens up Pimcore to more than 1600 channels and allows product syndication on a big scale. The challenge we have with the product sub integration is that we need to prepare the multidimensional and often very complex data model of Pimcore to a simpler data model for Product Hub. That means we need to select which data attributes we want to send over to Product Hub and flatten the data model out a bit. As the Data Hub already does a similar thing, we decided to integrate the Products Hub integration into the Data Hub and created an additional Data Hub adapter. And this is how it looks like and is configured.
A Products Hub configuration can be added to Data Hub as any other configuration, and it also follows the typical schema for the configuration. That means we have some general attributes that we can specify, like activating the configuration and setting a description. Then we have the schema definition, where we define what data actually should be exported in terms of the data attributes. So this is the place where the flattening takes place. There we select from one data object class and then configure the schema for the data object class. And this schema definition is similar to the one we have for the data object grids. So we have again the possibility to choose all the data attributes and also use some of the operators here to flatten out more complex data, like for example extracting out the name of the manufacturer relation. Then we also have the possibility to define image and video thumbnails that should be used when some asset data is linked to the data object. If nothing is specified here, then the original asset is delivered. Next step is to define the workspace, also very similar to other places in Pimcore like the permissions or also other Data Hub configurations, where we just add all the folders that should be included into the export to Products Hub. Next up is to define the trigger for the delivery. We will discuss this one in more detail in a later session because there we need some background information for this. And then last but not least, we set up the delivery endpoint where Products Hub is then getting the data out of Pimcore. So we activate the endpoint, define a security token, save the configuration, and job done. Pimcore is ready for the Products Hub integration at this point. In addition to exporting the data, it also would be possible to import orders that took place at Amazon or whatsoever and are imported into Products Hub and then pushed back to Pimcore. For that, we need to activate the order endpoint, specify a parent folder, and again the security token. And then every time when Products Hub pushes us back an order, an online shop order object is created in the corresponding folder so that we have all the information in Pimcore available. One last important thing to know about the Products Hub integration is that Products Hub allows to integrate multiple data sources and allows also to join these data sources. So it's possible to define multiple endpoints here at Pimcore side, for example in this case for products, and then another endpoint for the brands, and join these definitions into each other at Products Hub side, and this makes the endpoint configuration on Pimcore side a bit more flexible and a bit less complex.
So far for the Pimcore side of the integration. To see the Products Hub side of the integration, you either can have a look at the video that William did at the Inspire conference or directly visit the Products Hub webpage.